My name is Jim Crooks. I am your MC for today. And I am a scientist and associate professor at National Jewish Health, which is a respiratory hospital just down the street. And I perform research on climate change and air pollution and health and how they're all connected, which is the topic of today's event. And I want to thank you for being here, in person or online. It's great to have so many people here today interested in this subject and what it means for our state. And I particularly want to thank those of you who are here who are leaders in environmental and public health, because this event is really aimed at you. And I hope that you come away from this event more informed and more motivated to take action. And finally, I want to thank Boulder County, especially Susie Strife and Bill Hayes, for their leadership in putting together this event and without a whole lot of time to do it. So first, some housekeeping stuff. Information on Wi-Fi access is on these white sheets in front of you. The bathrooms are across the hall, across the main hall there. And please, before we dive into the event, I encourage you to silence your cell phone. We've all been that person. It's not a fun place to be. You don't want to be that person. So I'm going to start the conversation today by citing for you a simple fact of demography that I hope sticks in your mind after you leave. Half of the babies born this year in Colorado, half of them will live to see the turn of the 22nd century. It's kind of amazing, right? It's hard to believe, but 22nd century is only 80 years away, and life expectancy at birth right now is 79.5 years in the US. The time horizons we toss about when we talk about the climate emergency, we talk about years like 2060 or 2080 or 2100. These are not unimaginably distant times. These are well within the lifetimes of people alive today, people we know, people we care about, our kids and our grandkids, our nieces and nephews. This climate-driven disruption is going to be an inescapable fact of their lives. So rising seas, stronger hurricanes, toxic algae, more heat waves, more drought, more flooding, more air pollution, more pollen, more pests, more wildfires, more famine, more mass migration. If we do nothing, together they will come faster and faster, more frequent, more intense. If we do nothing, those babies born today are going to inherit a world of desperation. But we don't have to do nothing. There is still so much we can do to shift our path away from a cataclysmic future to a manageable one. And what's more, the actions we can take today don't just help those kids who are going to grow up in 50 years. These actions will benefit us all right now, immediately, even those of us who won't be around in 2040, much less 2080. Because cutting our carbon emissions now also means cutting today's air pollution. And that improves the health of everyone around us who likes to breathe. So today's panel is going to focus specifically on ozone, which is a dangerous air pollutant formed in the atmosphere from the combination of gases emitted through fossil fuel development and burning. Ozone arises from chemical reactions between two kinds of gases. On the one hand, we have nitrogen oxides that are emitted from car tailpipes and power plants. And on the other side, we have a class of chemicals called volatile organic compounds, or VOCs, gases like methane, that have natural sources but are also emitted during oil and gas development. Now, because we here in Colorado have lots of both, the Front Range is currently in serious non-attainment of the US EPA's ozone standard. And not just the current standard, I'm talking about the older, less stringent standard. We're still out of compliance with that. So strangely, in a rare area of bipartisan agreement, both our state's administration and the federal administration agree that our ozone level is too high. Now, why do we care if we have a lot of ozone? What does it matter? Why would Congress 40 or 50 years ago have required the EPA to regulate it? Well, because we know ozone damages our lungs. Scientists have known for 40 or 50 years that breathing ozone causes asthma attacks and exacerbates chronic lung diseases like COPD and emphysema. And what's more, over the past 10 years, scientists have discovered that the health effects of ozone are much more serious than even that. We found that breathing ozone increases the risk of heart attacks and strokes, and possibly even diseases you wouldn't even think of, things like diabetes and Alzheimer's. In addition, many of the gases that combine to form ozone are themselves dangerous too. Nitrogen oxides are lung irritants similar to ozone, and some of the VOCs, think of benzene. You breathe too much of it, it makes you nauseous, gives you headaches. And also, if you're exposed to too much, it can cause leukemia and other cancers. And to make matters worse, ozone and the VOC methane are also greenhouse gases that contribute to global warming and also to the local urban heat island. So these relationships between emissions, climate, the air we breathe, and our health are complicated and pretty difficult to disentangle. So we are incredibly fortunate today to have 4 esteemed panelists here to help us tease out these relationships and explain what they mean for our state. So we'll start off with a series of 15 to 20-minute presentations by each of our 4 panelists, then a 45-minute question and answer session and panel discussion, and finally a quick wrap-up and call to action. Now, before each presentation, I'll give a short intro to the speaker's work, but please note that their full bios are on the handout or on these sheets that are on the tables in front of you. If you have questions for the panelists during their presentations, please save them for the question and answer session. Now, to start things off, we have Dr. Detlev Helmig, atmospheric scientist and associate research professor at the Institute of Arctic Research at CU Boulder. He will talk about ozone, its precursors, and their sources along the Front Range. So let's welcome Dr. Helmig.
Well, thank you for the introduction, and thank you for having me here. Oops. Let's see if I can get to that's me, you know that by now. Okay, that's my first slide. So we just heard about this already, and I'm sure you've seen this in the news. The region has been reclassified as a serious non-attainment area for ozone. So I want to walk you through how we got there and where things stand, and maybe also give you some ideas where we are leading to. So ozone. Ozone, and thanks for the introduction again, is a gas we don't really want to have in the air. There's more than what's healthy for us, and it's a respiratory irritant. The health effects are all listed here again. And what's important to bear in mind is that we as people have different sensitivities to ozone. You know, for some people, a certain level may just be fine, for others may not. And our sensitivity may change through the course of our life, through the course of our health. You know, we reach conditions at some point in our lives where we become more sensitive, and where levels that we tolerate well at this point may all of a sudden become a health concern for us. The people that are most susceptible are groups are elderly, children, even mid-age healthy people working out outside. And beside those health effects on people, ozone also impacts vegetation pretty severely. It inhibits growth of vegetation, and it's a pretty notable loss to agricultural yields, to the farming community, and it's a climate gas. It's actually a real significant climate gas. The increase of ozone that we're experiencing right now in the atmosphere is thought to be on the order of 10% contributing to the climate forcing. So where we are compared to others, this map shows the currently designated non-attainment areas for the ozone standard. And you can see we're not alone. There are other regions in the country that struggle with high ozone. The map hasn't been updated, so this shows this region here still as yellow. So this will be pinkish, or should be pinkish by now. There are a few areas in California that have a more severe designation than we have here in this region right now. But other than that, there's really there are no other counties in the country that have this serious non-attainment classification. So, you know, most areas in the countries have quite a better ozone condition than we have here in the Front Range at this point. So ozone is not emitted ozone is not emitted, and I just recognized, you know what, this actually does not have the updated presentation. These are some older slides from last night. I'm not sure what happened, but it will be fine. Oops. So ozone is not emitted. It's a very important point. Ozone is not emitted, but it's formed in the atmosphere. It's formed in the atmosphere from emissions of what we call precursor gases. Ozone is not emitted. Often you see in the paper emissions of ozone. I said, no, ozone is not emitted. It's formed in the air from atmospheric oxygen, nitrogen oxides, and volatile organic compounds, and it's only formed in the presence of intense solar sunlight because it's a photochemical reaction. So you need all three of these components. And so where do these VOCs and the nitrogen oxides come from? Well, there's a whole array of sources. VOCs, come from everything that's shown here: vegetation, household products, emissions from cities, oil and gas development, power plants, automobiles, all this contribute to VOCs. Nitrogen oxides, again, there's quite a few different sources of there, and these all mix together, and when there's sun, bang, we get the ozone. Okay, and there's a lot of debate. These source categories blaming each other. How big are these arrows, and who's driving this? How much is coming from which of these sources? So I want to show you some data from the region. And I'm going to come back quite a few times showing you data from the Boulder Reservoir. I want to just show you where that is so you understand where these measurements are from. This is the front range here. All these dots are oil and gas wells, some 25,000 in the region. Denver's down here. Boulder Reservoir is right here on the northeast corner of the city of Boulder. Very simple station facility. And I'll be showing you quite a few observations from there. So let's start out just a few days of ozone last summer. So this is from July last year. So ozone goes up and down every day because it's formed. It's formed in the air every day when there's sunny conditions. You have the precursors, it goes up. And then since it's such a reactive gas, at the end of the day, it disappears because it breaks down, it reacts with other things, it gets deposited, and then the next day it starts all over again. Yeah? But now look, it's not the same every day. So you have some days where it gets pretty high, and this is the air quality standard here, which is 70 parts per billion. On other days, it's not, it's much flatter. So what's going on here? Well, the conditions just weren't right. Maybe this wasn't a sunny day, or it was more windy, air got blown out of the area much quicker. And then what happens here in this region quite often is we have these afternoon thunderstorms, and they cause a lot of mixing, the sun disappears, and the ozone production just stalls. It stops, it doesn't get there. Yes, it's highly variable, and it's highly dependent on meteorology in addition to the emissions. So looking at a full month of ozone data from the Boulder Reservoir. So now you can see again it goes up and down every day, so there's 30-some days. And this is the standard here, the 70 parts per billion. And you can see it, it goes above that standard pretty regularly. This was a really high ozone month in 2018, July. And you've got to be paying attention to how these data are plotted here. There's actually 3 different data series. One are the blue dots are the hourly data, the minute data, then the red ones are hourly averages, and then the yellowish orange one are the 8-hour averages. So when you average these data over a longer time period, the peaks become smaller. Yeah? It's very important to understand, because here in the United States, we're looking at the 8-hour average, and the 8-hour average is actually quite a bit lower than these daily maxima that we see every day, because we average over 8 hours. Okay, so you may have peaks that are, 100 ppb here, but then if you average over 80 hours, this may just be 85 or 90 or something like that. And the way the compliance with the standard is determined, it's about as complicated as you can imagine. The definition is down here. So compliance with the Ozone National Ambient Air Quality Standard is determined by 3-year averaging of the 4th highest annual 8-hour ozone average. And that's truncated. My goodness, my goodness. It took me years to understand that. So what does it mean? So you don't take these high extreme values. you take the 8-hour average, which is the yellowish value, which is smaller than the higher ones. And then you don't take the highest of that, you just take the 4th highest per year. So skip this one, skip this one, skip this one, skip this one, and maybe now you're here. So you consider, maybe this value now for evaluating, are you in compliance and not? But that's not all. So you may have, maybe this is the 4th highest of the year, but now you average those over 3 years in a row again. And then you truncate it. So if your average is 70.9, it's actually taken down to 70, and that's still compliance. 70 is compliance, 71 would be non-compliance. And you can see here in this comparison that in the United States, how the United States ozone air quality standard compares. It's more protective than in China, but it's actually less protective than in some neighboring countries. Canada and the EU and the World Health Organizations all recommend or have ozone standards that are actually more protective than what we have in the United States here. And then this is shows you, I've shown you data from the Boulder Reservoir. These are data from the whole state network in the Front Range. There are all these different sites listed here. This is a summary from 2018, and that shows you then the highest value at each site, the second highest, the third, and the 4th. So what will matter is what's in this column here, the 4th highest. This is really what's considered to gauge compliance, and you can see that in 2018 there's quite a few of these sites that all were above that standard. So it's not just the Boulder Reservoir, not just one site, but across the whole Front Range, we have monitoring sites where ozone is elevated. Okay, so that was just 1 month. Looking at the whole summer 2018, so these are the 5 summer months, there were a lot of occurrences where ozone was above the standard. It was regularly, month after month, many days, many hours, many days, 32 days, where the 8 hours average ozone was above the standard at the Boulder Reservoir. Okay, so how has ozone changed over time? Is it getting better? Is it getting worse? So that's when we do a trend analysis. So, and I want to give you some background on what to watch out for when you hear or see about ozone trends. So let me show you some examples. This is a map showing all the places in the state of Colorado where ozone has been measured. There's ozone data from more than 80 different places. And I'm going to just pick 2. This is a blow-up of the Denver metro area here, and I'm just going to compare 2 locations here. This is Welby, and this is NREL, which is down in Golden, so not too far from here, one west of Denver, one in the northeast of Denver. And these are the data. These are thousands and thousands of measurements over 15 years. So the top one is the Golden side, and the lower one is the Welby side. So what you see here, it goes up and down every year. So what's happening in the summer, you see these peaks. In the winter, ozone is lower. That's when you go to the lower end here. So, how do you figure out the trends? Well, actually look at it. Does that look like overall ozone has been going up or down? Hard to tell, but it looks like almost, it's been going up. At least down here you can see this. So then this is statistical analysis. Every year, the data are binned, and we look at the medians here in the middle, the percentile distributions, and you can see the low values actually have come up, the higher values, about the same. Then if you do a trend analysis, these are the same data sets, but this uses the summer data. And here we put these lines, which are linear regressions, through the high values, the high percentile values, the medians, and the low percentile values. You can see there's, for those 2 sites, which are so close together, they're quite a bit different. But you can see it's mostly, for these sites, these slopes are positive, which means ozone has gone up in the high percentile, it's gone up in the median, and the lower end has gone up. For this site here, there's a tendency that the high end of the distribution has come down. So if you look at these data from different sites in the Front Range, and these are 6 or so, so that looks at the 4th highest, so the 4th highest 8-hour ozone average for the summer. I explained to you how that's done over some 14, 15 years. for these Chatfill, Rocky Flats, NREL again, Fort Collins, South Boulder, and BIO is a site in Erie. And gosh, you know, what do you make out of that? It bounces around like crazy from one year to the other. You know, so if somebody tells you, well, ozone has gone up, you know, yeah, you can justify this. During those years, ozone has gone up. You could also say, no, ozone has come down if you just take this year. If you just forget this one extreme year here and look through everything, you could argue this is flat. So why does it bounce around like this? Well, it's strongly dependent on the weather conditions. You know, you have a windy summer, you have a cloudy summer, lots of thunderstorms, and you may end up with overall lower ozone levels, you know, something like here. Then you have a summer that's warm and hot, and you may have high days here. So to say ozone has come up or down, you really need to factor in, you know, this high variability and the dependency on the weather conditions. And that's actually been done. It's a very nice paper, was published a few years ago, and that determined the dependency on the ozone, on the weather conditions. So these are, I think, again, the fourth highest ozone values for 14 stations in the Front Range, and then the line or the curve through this is the median of all these data, bouncing around, as I showed you before. And then this dependency on the weather, on the climate in each summer, was determined and was corrected from the data. And that down here, this is now the corrected plot. You see there's far less noise. It makes much more sense now because this climate dependency has been taken out. And doing that, the author concluded that for 14 Front Range sites surrounding Denver from 1995 to 2013, the corrected trends show a slow general increase in the Front Range ozone. And they actually thought that this dip was because of the recession in 2009. There was less activity, fewer emissions. So for that window, at least the conclusion was, doing all this correction, this very careful work, ozone has come down. It's gone up slightly. And this is how the ozone in the Front Range compares to other regions across the country. Downwards pointing arrows here mean ozone has come down. Upwards arrows mean ozone has gone up. And you can see most places across the United States, arrows are going down. So there has been a general improvement in surface ozone across wide areas in the United States. But here in the Front Range where we are, the behavior really deviates from the larger scale behavior we've seen across the United States. So now, what's the influence of oil and gas development on ozone? And that's actually been looked at for at least some 10 years. This is a really nice set of data that was analyzed by the state. And it shows down here, taking ozone data from those 4 sites. This is Fort Collins West, Rocky Mountain National Park, Rocky Flats, and Highlands Ranch. And it looks at, you know, when during that time, high ozone occurrences were seen at these sites, where did it originate from? And this is shown by this heat map. So high ozone at these sites originated mostly from this area north of Denver. Again, this is the same map area. It shows the same location, and it shows the oil and gas well distribution. So that really raised some eyebrows. Well, why is there this overlap of the high ozone source region with this, the high density of oil and gas wells? And we've looked at this again now, taking data from the Boulder Reservoir, just the last 3 years, so 10 years later. And this looks at where did the air come from when ozone was higher than the median and when the standard was exceeded at the Boulder Reservoir. So we're at the Boulder Reservoir, and where did air come from when we exceeded the ozone standard during the last few years? And this shows you that the transport is associated mostly from east of Boulder County, and most of this overlaps with Weld County. And again, if you do these are the same map areas, the associations with oil and gas, you can see that for the Boulder Reservoir, pretty much all of the high ozone events originate in Weld County. Okay, and we're actually not alone. This has been shown in quite a few other studies, and this is just a few pieces of literature I'm pulling out here. There's a study that by NCAR scientists that stated that on average oil and gas emissions contribute 30 to 40% to the total ozone produced in the region. There's another study that looked at the transport of high ozone. It concluded that 65% of the high ozone events originated in the sector that overlaps with Boulder County. A NOAA study from 2017 concluded that oil and gas precursors contribute in excess to 30 ppb to the ozone growth. And another NOAA study down here again showed that there was a high association of elevated ozone with oil and gas source regions. So where are we going from here? In a changing climate, climate that changes towards higher temperature. It's actually looked at. There are quite a few papers out there, and I only pulled one here. And so the title is Observed Relationship of Ozone Air Pollution with Temperature and Emissions. What this particular study found, I underlined it here, that with every degree in warming, ozone increases between 2 to 3 ppb, and I've seen articles that state as much as 6 parts per billion. So why is that? Well, emissions generally increase in a warmer climate. The reaction rates become faster, and there's more efficient ozone production in a warmer climate. So as we're moving towards a warmer climate, we're actually predicting that there'll be more aggressive, more ozone production in that environment. And that's that's my last slide. And actually now I find my updated presentation. They're both still on here. And I had another big black box over there. So the take-home message, in a warmer climate, we're expecting more ozone. Yeah. So we're to battle that. The only approach is that we can't change the meteorology. We can't change where we are. We've got to bring emissions down. And the more ozone in the warmer climate will drive a warmer climate. Yeah, so it's a circle. It's a vicious circle. That's what we call a positive feedback. So warmer climate, more ozone, warmer climate. So the way out of that, really, our best option is to bring emissions down. And that's my concluding remark. So thank you.
All right, our next speaker is Dr. Gabrielle Petra, atmospheric scientist with NOAA's Cooperative Institute for Research in Environmental Sciences in Boulder, and she will discuss what we know about the climate crisis and how ozone and methane contribute to it. So welcome, Dr. Petra.
Let's see. Is the clicker here? You've got it. Okay. All right, so thank you everyone for joining us today. I think it's exciting to see people from so many different, line of work and people interested in more discussion among different expertise. So I work at CU Boulder in one of the cooperative institute for NOAA. So we are based in Colorado, and we study mostly the atmosphere. Our particular lab studies climate forcing and all the variables that are involved, including greenhouse gases, water vapor, clouds, radiation. I encourage you to come visit us and see how we conduct our measurements and how we do the analysis. And we're always happy to come talk to you also wherever you work. So my plea today is to try to get together and protect our atmosphere more effectively than what we've done so far. And all of this are going to be based on as much data as I can. So I'm speaking, on my own behalf. I'm not representing any of my employees or sponsors for the work we've done. So our atmosphere is vital, and some of you may not have had much studies about why it is so important in our climate system and in allowing life on Earth. But without greenhouse gases, without this atmosphere and natural level of greenhouse gases, we would be a frozen globe. Okay, natural greenhouse gases, ozone, all that we have in our air allows us to have liquid water and water vapor. Our atmosphere also absorbs dangerous radiation, including UV, as you're all aware of. And also the atmosphere carries energy and water around, okay? The poles are getting less energy than the equator, and all the movements that you see in the atmosphere and in the oceans are to balance this energy that's coming differentially at different latitudes. So what we are doing now to our atmosphere is we're changing its composition radically. And we are doing that with gases and sometimes particles that have impacts at different scales. So I'm showing here we go from local, regional to global scale. And in Boulder, at NOAA and CU Boulder, we study all those scales. And we'll conduct long-term measurements at the global scale to track greenhouse gases level every week. And that's been going on for over 40 years. We also study ozone-depleting substances that the ozone up high. We care about that one. It absorbs UVB radiation. And you all heard maybe a long time ago about the CFCs. And these CFCs contributed to the loss of ozone in the high latitude over the southern hemisphere. This is under recovery, but it's still going to take decades to recover, even though emissions are close to zero now. So there's a lag. It's the same for greenhouse gases. We'll get back to that. Ground level ozone is also something we measure. We use aircraft, we use towers, we use mobile vehicles with instrumentation to track ozone in different places. Particulate matter is also measured at different places on Earth by our teams. And then we started studying air toxics, especially benzene, because we think that this type of pollution has not been investigated enough, especially in industrialized rural areas like we have in Northeast Colorado. So our main expertise, I want to emphasize that again, is at the global scale at NOAA. To track pollution, especially greenhouse gases, over decades globally, you need to have the most precise and accurate measurements anyone in the world can obtain. So we create our own calibration scale. NIST, at the time, 30, 40 years ago, could not deliver standards for calibration that were of quality and accuracy that was required for the job and the interpretation we needed. So our people had the vision to develop this capacity, and we've been maintaining it for the entire world. We are the central calibration lab for greenhouse gases. That means we deliver standards to labs around the world. These measurements are important because they tell us how the atmosphere is changing, and based on that, because we measure multiple species, we try to understand what's forcing those changes in terms of sources and things. We also use our measurements. We have a more dense network over the US, and we collaborate with other countries that have similar networks to try to understand emissions at a more regional, national scale or state scale sometimes. So emission inventories are usually a bit like a spreadsheet. There are numbers that are your best guess at what the emissions are based on activity and emission factors. When you do measurements in the atmosphere, it's telling you the truth. You need the right interpretation, but there's nothing hiding from the atmosphere. If it's been emitted, if it's living long enough, you're going to measure it, you're going to see it, and that's something we rely on. And then our greenhouse gases measurements around the world and averages that we can do are fed directly into climate models. And that's going to be important because people, to try to predict future climate, try to reproduce past climates. And they need to have the right forcing for greenhouse gases to try to reproduce the observed temperature change. So talking about greenhouse gases, this is the image, maybe if you've seen Al Gore's movies, that's when, I won't do that today, but you go on the elevator and you go higher because we've seen a really upshoot in CO2 levels since pre-industrial time. And these levels that we have today, we haven't seen for close to 3 million years. Put that in perspective. Agriculture started 10,000 years ago, right? Our civilization, the type of society we have today, has never seen levels we have now and that we'll have in the future. If we stop completely CO2 emissions today, we're not going to stop the warming yet. There's too much that's been rolling, you've changed the atmosphere, you've changed the ocean, a lot of the heat is in the ocean. The equilibrium will take thousands of years, not millions, thousands of years. So the warm will, even if we stop emissions today, will be 0.3 Celsius by the end of this century. So it's important to understand that whatever we do will take time to have the reaction we want to see. But the more we wait, the worse the reaction will be. We cannot say we were not warned. Jim Hansen did a testimony in front of the Senate, the US Senate, over 30 years ago. And he had done an extensive modeling that already showed at the time that the type of temperature increase we were seeing was beyond the noise that we had experienced in the past. And the only way to explain this increase was by having increased greenhouse gases in our atmosphere. There's a very strong consensus in the scientific community, and we're always happy to discuss this more. What happened in those 30 years? Fossil fuel emissions of CO2 increased by 70%. So it's one thing to know, it's one thing to become aware. The emissions are continuing to increase or being flat, and this is not what we want to see. So as I said earlier, we measure greenhouse gases, and that's one of the diagnostics that we produce. Peter Tans in our group, who's been leading the carbon cycle group for many years, he just retired, looks at the annual increase in CO2 for the global atmosphere. And you're seeing the black lines are showing you the average for different decades. And we've been going in the 1960s from a little less than 1 ppm increase per year to over 2 ppm in recent decades. And some of the recent years have seen the largest increase ever recorded by our group. So there's questions about not just our emissions. What are we going to choose to do as, a society, a state, nation, the global world? There's also what are the natural feedbacks that we may try to, understand and that we don't yet know what they will release. And one of them is the permafrost. We have a lot of frozen carbon in the high northern latitude, and some of that carbon, as the soil is defrosting, is going to get released. It's a question, is it going to get released as methane, which is even more potent than CO2, or as CO2? That's something we're monitoring very extensively with collaborators in different countries. Now about inventories. This is a favorite tool for air quality managers to look at and try to understand trends, are the regulations working, etc. Well, even though we don't regulate emissions in the US for greenhouse gases, there's been extensive work done recently to try to better understand methane emissions from oil and gas systems. And maybe some of you are aware of the EDF-sponsored studies that just happened. NOAA was involved in several of them. So we are doing what we call the top-down, the measurement atmospheric-based estimate of emissions, whereas EPA does the bottom-up. They do the accounting, they do the spreadsheets. And the different lines that you see are to show you how differently the EPA estimates comes out for different years that they do the calculation. So we always go back to 1990. Developed countries have to report national emissions of greenhouse gases for different sectors to the UN. And we've been doing that since the late 1990s, but we always get the computation go back to 1990. The lowest estimate was for, I think, the estimate they did in 2010, and then they revised their methodology, and the estimate shot up and went to close to 10 teragram per year for methane, and then the estimate went back down. So you see that we have a huge uncertainty, clearly, in those estimates, even at the national level. The red square at the top is what EDF estimated based on 5 years of research for the country for 2015. So 5 years of research gave us one number for the entire country. But this number is probably much better known than what the EPA has ever done, because it's based on actual real-life measurements. So we have a huge uncertainty, we have a big gap, and unfortunately, these probably translate into inventories at any scales being quite uncertain. more work needs to be done on that. So I've shown you that measurements at the global scale are very important to track what greenhouse gases are doing for the global atmosphere. Regional, local scale measurements are really important to understand the mixes of sources you have in a region, but also what your residents are exposed to. Do we have enough air quality sensors in the region, all throughout the state? It's an open question. I think that needs to be looked at. Do we know how accurate our emission inventories are? I don't think so, and I'm going to show you something about that. We have estimates, here I'm showing something from a newspaper, estimates of CO2 emissions for the state of Colorado in the black bars, and then projections for future years are in the pink bars, and then the horizontal lines are targets based on what the Climate Action Plan has set. This is, when you're a scientist and you see projections that are way higher than your targets, you start panicking because you're like, do I have a good plan to get there? We have lots of questions for today. Sorry, I'm not just giving answers. We're gonna put questions on the table and then we can discuss them. So there's gonna be a lot to do to tackle the huge challenge of meeting the targets. Now, this is a very important graph, and it can look boring at first, but it's very critical. This is showing you VOC emissions, so ozone precursors emissions, from oil and gas systems for the ozone non-attainment area. All right? The black dots at the very bottom are state inventory estimates. Good news, are going down in the inventory world. Is it happening in reality? Maybe not. What we have at the very top in the circles are estimates based on atmospheric measurements, some that we did with EDF sponsors in 2012, the very high bar before much of the new regulation was put in place. And then in 2014, the FRAPPE campaign that was partly sponsored by CDPHE also found that oil and gas VOC emissions in the non-attainment area were underestimated by at least a factor of 2. Even the EPA, so the state has its own way to compute emissions. The EPA also dictates how states should compute emissions, and they find something that's also double than what the state is doing on its own. We have a huge problem here. Which numbers should we trust? Can we trust trends even at this level? I think if we want to talk about targets, we need to know our baseline. If you want to go on a journey, you need to know where you start from, and you need to understand that well to get the best policy and reduction plan possible. We have a lot to do. And having worked on oil and gas emissions for over 10 years, I feel that what we've learned from atmospheric studies has not been taken seriously at many levels. And I'm sorry to say, I have a daughter, and I really hope that by the time she's an adult, we got our acts together and we make the air she breathes and other kids breathe and our grandchildren will have much safer than what it is today. Now, looking beyond Denver, you've all seen that population has increased by quite a bit, close to 600, 700,000 people. Well, a lot of these were adults, above 15 years of age. They come with cars. The number of cars has increased also. We have close to 5 million cars for a bit less than 6 million people in the state. Most of them are gasoline vehicles. Well, where you have also oil and gas expansion, you have population expansion. As we've shown earlier and Detlef mentioned, we know that north of Denver, most of the ozone production is related to oil and gas production, and likely some mobile sources too. But oil and gas production is the leading cause. There's almost no sensors. That's the map that you see. There are sensors in Greeley, Fort Collins, Longmont now, Boulder, and then the Metro Denver. Are we really paying attention to all these people that live in the middle? Another big piece is that oil and gas ain't what it used to be. If you've never been in the field, just please take a field trip. There's a lot of people in the room that I see that I know that would be happy to give you a tour. These look like worse than gas stations that have more regulation than they have, all right? So this is one location in Western Greeley where Ingrid, who just graduated this summer, conducted measurements for several weeks of BTEX. BTEX is benzene and some other nasties, air toxics, that come together as part of crude oil and natural gas extraction. So what's been amazing, I'm a scientist and I try to have a holistic approach. I come from a farming community and I went to jump into the atmospheric world because I thought, I care about the weather. My grandparents were always worried about the weather. And I'm like, I need to understand our atmosphere. I need to understand what's driving our climate and our weather. And now I became interested in air toxics because I see and I hear people complaining about odors, but also sometimes health issues. So benzene has been regulated in the US and in other countries for a long time. Where it's used. No, not where it's used, I'm sorry, where gasoline is used. So you have regulation on refineries, gas stations, and vehicles. There's very little benzene specific studies on where the crude oil is being extracted. This is a huge gap. So we decided with NSF funding, NSF being the National Science Foundation, non-partisan source of funding for researchers, to go ahead and look into what BTEX levels we would see close to large oil and gas wells. And before we go to that, another big source of benzene that we found that's not really looked at is the produced water injection facilities. And Rachel Eddy from the University of Wyoming did several campaigns with us in the Front Range where they had a really expensive instrument that could measure benzene at 1 second resolution and very high detection limit. And we found levels that were up to 620 ppb of benzene. This is over the roof. And you have a few houses in the area, and you know, several hundred meters further, you still were at 100 ppb. This is like a different world. Air toxic studies, the measurements from Ingrid, who is right here, who can answer questions that you have. This is hourly data that Ingrid plotted for us today, and we are comparing specifically with the standards that the state of Colorado has decided to use. Understand, the US is one of many countries that does not have a standard for ambient benzene levels. There's only 52 countries in the world that do. Russia and Syria do. We do not. All right? So, and it's based actually on the California standard, and it's 9 ppb. We have 2 points that go beyond this 9 ppb standard. So I think we are at a crossroad where we know air pollution and climate are not going to get better unless we take strong, concerted, well-thought actions and effective. So my question is, how could scientific inquiry, methods, and finding further support local and state air resource management and sustainability program? I think the role of science has been very minimal, and it needs to be coming at the table where people discuss. And I have a more specific plan because in the past, when I've asked air quality managers what research questions they wanted us scientists to investigate, I got no answers. I have ideas. A lot of us have ideas of what should be studied. And if you're ready to discuss, we're happy to help.
All right, so our next speaker is John Putnam, Director of Environmental Programs at the Colorado Department of Public Health and Environment, and former chair of the Regional Air Quality Council He will tell us what the state government is doing to address the ozone problem. A big warm welcome for Mr. Putnam.
Terrific. Thank you very much. Good morning. Very pleased to be here this morning to talk with you all about, I was going to say Tabor, but we're actually here to talk about air quality. Actually, we're here to talk about Tabor because I think picking up on some of Dr. Patron's comments, in addition to the numbers not lying in terms of atmospheric measurements, it's a question of interpretation. Budget numbers also don't lie, and we do basically what we can do with the budgets that we're given, and we've been flat for years. And I think that reflects the fact that if you look at some of Dr. Helmig's data, some of Dr. Patron's data, you see a cutoff there kind of right in the 2013, 2014, maybe a little bit into 15. A lot's happened in the last 5 years, and we haven't had the money from the federal government. We haven't had a consistent investment on the state government to keep digging in on that information, which is what we need. I think the good news is that the governor and the legislature, I think, are prepared to make those investments, and we'll talk about that. But let's back up for a minute. Actually, one other just quick, make sure I've got this working correct. One other, I think, critical piece going to Dr. Patron's conclusion, and I think what Dr. Helmig was looking for as well, we definitely want to engage and accept that offer and are working with the Air Pollution Control Division to try to figure out how we can better engage with the research community. I think it's a little bit of a challenge for us because it's hard to have the conversation without having resources to actually deploy at the problem, but I think we're changing that, and so the time is ripe, and we will be reaching out shortly to have some of those conversations. So more to come. I think a lot of real potential here in the new year. I'm going to skip really quickly over the first few slides because I think they've been ably handled by my colleagues here. We're focused on a lot of the same issues: ozone, climate change, air toxics. Want to mention two others just that haven't been mentioned nearly to the same extent. The first is particulate matter. I think we are currently in compliance with federal particulate matter standards. I'm also not convinced that the federal standards are sufficiently protective. And you probably saw that there was a decision made by EPA to move forward with the existing PM 2.5, which are the fine particulate standards, despite considerable scientific evidence that those levels should be lower. So when I'm thinking about our program, I'm also concerned about co-benefits that we can get from PM control and try to better understand some of the health effects of PM 2.5. That being said, we do have our hands full with ozone and climate change and some of the local air toxics. So it's something that I think we're trying to fit in to look for opportunities to control that as well. Indoor air quality, I think, is another area that we, typically, and this is true on the federal level, I think it's true at the state level, and indeed at the local level, but given that we've got a great representation from local public health today, a lot of this happens on the local level with building codes and other steps that are being taken. And given that we spend about 90% of our time indoors, thinking through what's actually happening on the indoors is critical to understanding public health, especially if you're somebody like me who has asthma and has to worry about the entire exposure. Skip over. So this is a different slice at the data, I think, than Dr. Helmig presented, and I think gets to some of the same point, but maybe in a different way. This takes a look at the what's known as the design value, which is that hideously complicated number that Dr. Helmig referred to based on the way that EPA has structured the standard, which is the 3-year average of the 4th highest level each year based on an 8-hour measurement. Try saying that 5 times fast. The key thing is that we have made generally progress on that front, but that the actual location of that shifts year to year. Even if we take that that progress over time as we see it. What you'll see, and I'm going to move over real quickly. Let me see if is there a pointer? If you see, there's two standards that we're working against. There's a 75 part per billion standard, which is the older standard. That's the one that we were just put into a serious status for. And then there's a 70 standard, and then questions, as Dr. Helmig raised, about whether even that's sufficiently protective. But let's start with the standards we've got. Clearly, we are a long way away from meeting those standards. And the trajectory that we've been on has not been sufficient to get there in the next few years, which we're required to do. So we need to find a way to bend that curve. And the question is how to do that. And to do that, you need to understand the nature of the problem, the location of the sources. And I think I have an older version in here too. So I actually had a little bit newer information. We're working on estimated 2020 inventories as part of our process. But this still gives you a flavor for total big picture. So this is looking at oxides of nitrogen first. As Dr. Helmig pointed out, ozone is created primarily as the result of reactions with oxides of nitrogen and VOCs in the atmosphere in the presence of sunlight. And what you'll see here is that we've made progress on the NOx front, but it's still pretty important. And it's one that I want to make sure we're paying specific attention to. One of the things that's happened in the last 3 to 4 years that we really need some more data and analysis on is what's the effect of having closed all the coal-fired power plants in the non-attainment area, almost all of which happened after the Big Frappe campaign that Dr. Petrone had mentioned. We need to understand that, as well as the continued reductions of VOCs and NOx from mobile sources, some of the other pieces. It may change some of the way that policy is derived around that. We will be engaging in extensive photochemical modeling later this year. EPA's most recent version of that model has been delayed, and so we've delayed that modeling probably by a few months. But we will be doing that to support our next state implementation plan, and that's a place where we definitely welcome and would expect engagement with the research community here in Colorado. One of the critical points, I think, about NOx is that while we've seen reductions in vehicles, both on-road and non-road, it's still the substantial and dominant part of that. And one of the reasons that you'll find kind of in the south part of the metro area, and especially driving the Chatfield monitor, which is currently one of our biggest problems, that's dominated by those vehicular sources. And we'll also note that oil and gas is one of the few areas that actually increased in our estimates from 2011 to 2017. So that will be the subject of rulemakings that we have coming up later this year. So moving to the next one, this relates to VOCs in the inventory that we have. And what you'll see there is by far and away, oil and gas is the largest part of that inventory. In our view, it's been coming down. I think to Dr. Petrone's point, yes, I think there are definitely flaws with the EPA approach for measuring those. There are also concerns with the so-called SIT inventory tool, which we've been using historically. It's one of the reasons why the legislature directed us and the governor directed us to update those inventories. Just today, we're starting that stakeholder process, so I'm hoping everybody can leave here, go to Glendale and engage in our process, or head up to Glenwood Springs, where we'll be talking about that engagement process tonight. We want to do a better job, and one of the biggest challenges we have is with the oil and gas inventory. It's also one of the reasons why a big focus of the rulemaking that the Air Quality Control Commission concluded last month was greatly enhanced reporting requirements for emissions for all stages of development and drilling. But beyond that, we need the tools to come up with better inventories to kind of close that gap between top-down and bottom-up approaches. And that's tough because it does require resources to get there, and I'll come back to that point. Going, I think, to some of Dr. Helmig's points, and again, this just reinforces some of the same points. One of the areas that's a great challenge in Colorado, and again, it depends on whether you're looking at averages or looking at peaks, but based on the photochemical modeling that's been done by the RAC and done by CDPHE, we find that on the biggest spikes, and this is for the NREL site in Golden, which is one of the sites that Dr. Helmig pointed out, that for those biggest peaks, roughly 75% of the emissions contributing to those peaks came from outside of the state. Now, for other monitors, other days, there may be larger contributions from in-state sources, but one of the challenges that we have to work with here is that we only control that slice of the pie, which maybe is a quarter, maybe it's a third, depending on how you slice it. But even when we make what we think are heroic reductions here, it's a relatively small amount of movement on the big piece, which means we need to make bigger changes here to be able to reduce the overall numbers, which 75%, 60%, depending on how you slice it, are coming in transport throughout the country. It's one of the reasons why we have to work closely with our states, and one of the areas where, once again, we're suffering from the fact that the federal government is not doing its job right now, not keeping up the pressure on mobile sources in particular, the oil and gas industry in particular, to be able to keep reducing some of those emissions from our neighbors. We don't control what's happening in the Uinta Basin, although we try. We don't control what's happening in the San Juan Basin. The good news is I think market forces are driving closure. You saw the announcement that not only will Tri-State plan to close the Craig Station in Colorado, which is incredibly helpful, but also the Escalante Station in New Mexico. That will reduce the transport of those precursors into Colorado and hopefully reinforce the efforts that we'll make here. Dr. Helmig covered this, so I won't spend a lot of time with what's happening in the rest of the state. Quick summary on that front is that we're just below the 70 part per billion standard. Elsewhere in the state, Colorado Springs is dancing very close to that standard, and another bad summer like we had in 2018, again as a result of bad weather as well as emissions conditions, could pop us over that standard. And so we want to make sure we're maintaining a statewide lens to review emissions throughout the state. And one of the things that we see is, especially on areas on the western slope, the western side of the state and the southwest side of the state, those are significantly affected by oil and gas activity as well. Very quickly, again, similar sort of numbers from greenhouse gases. These were generated with a SIT tool that Dr. Petra referenced. It's not perfect, but the general approach, I think, is about right. And one of the things that we're working on, and look forward to all of your engagement, is how we improve these numbers. You'll see that in 2015, the largest source of greenhouse gas emissions in the state was electric power. This is going to flip as of this year as a result of the closure of a number of coal facilities, including all the coal here in the Front Range, and remains a significant focus of our activity along with our partners in state and local government coming up. What that means is that transportation will next be the lead, and while we're still getting the benefit from older cars being retired, replaced by new vehicles, we're not seeing the same forward progress on a federal level for new emission standards. At the same time, we're obviously seeing growth in vehicle miles traveled. It's one of the reasons I unfortunately need to leave a little bit early today to head over to a joint meeting between the AQCC and Transportation Commission. We would like to tackle that problem. It's a very difficult challenge as a result of federal preemption, and we're spending a lot of our scarce resources right now fighting rearguard battles with the federal government at the same time that we want to try moving forward ourselves. But it's what we need to do if we're going to meet our ozone and climate challenges. The third largest sector in that, again, depending on how you measure it, that could flip with oil and gas, but again, for general magnitude is important, is home heating and building heating. There's a substantial amount of natural gas burned and then leaked as part of that process. So over time, we need to take a look, how do we electrify that sector? How do we electrify the transportation sector? These are massive economy-wide changes, and we need to do it in a thoughtful way. But we also need to tackle that early, which is one of the reasons we passed a ZEV rule last year, why the legislature passed a number of rules related to appliance heating, taking a look at electrification. The Energy Office is doing some very interesting work on that front. And then you get to oil and gas, and that's a place where, depending on how we characterize the global warming potential of methane, this tool uses a 100-year factor, which puts it about 25 times the potency of CO2. One of the things that we're going to look at, and we're very interested in your views on, would be whether we should move to a 20-year time frame, which bumps that up to 86 times. If you do that, it would roughly triple the size of that bar just by itself, putting aside questions about how we count tons of methane. But that's a critical question, and I think reinforces the importance of Senate Bill 181, passed last year by the legislature and signed by the governor, and that we've started our rulemaking process with our first installment. But we're going to keep going with that, and we'll be doing a number of rulemakings to further restrict emissions in that sector this year. So it is coming up this year, just from a rulemaking perspective. The first, as I mentioned today, the kind of most critical first rule that we're going to be undertaking is discharging the mandate from Senate Bill 96, which directed us to update the emissions inventory and impose emissions reporting requirements across the sector. We took the first step in doing that for oil and gas sources through the rulemaking that we conducted last month, but now we're taking a look at other sectors across the economy and trying to figure out how to make that work, as well as to tackle some of those questions about how to measure the potency of methane. In addition, we are strongly considering and intend to propose regulations on hydrofluorocarbons, again, another incredibly potent greenhouse gas, maybe 10,000 plus times the potency of CO2, admittedly in small amounts, but it's one of those places where we need to tackle that. We would be well ahead of any other state in the country. Again, the federal government was making progress on this front. A court knocked back that rule, and the current administration has left that sitting. So once again, it's left to the states to pick up the banner and move forward in that process. On a parallel track, being led by the State Energy Office, but one that we're actively participating in, we're going through a statewide greenhouse gas reduction roadmap process, similar to the process that's been done in California, New York, Maryland, Minnesota, other states, to really look at, on an economy-wide basis, how are we going to fill that gap between the very high emissions inventories that Dr. Petra pointed out and the very aggressive targets that were set by our state legislature and governor last year. We view that work as imperative, but one that we're going to be moving forward. As I mentioned, we've got additional Senate Bill 181 rulemaking that we'll be undertaking that will not only look at continuous emissions monitoring, a key gap that is really unfilled throughout the country and indeed throughout the world, but also further controls on things like pre-production activities. Senate Bill 236 directed Excel to come up with a plan to reduce emissions by 80% by 2030. We're working with them on that. We've been working with Tri-State related to the announcement they made last week to further retire coal plants, and we're talking to the other states' utilities. We're going to make big progress in that sector. Stay tuned for further developments there, and happy to talk about some of the other pieces. I'll also mention coal methane is one other piece. It's low-hanging fruit. It's a declining sector as coal has been reducing in production and coal mines closing, but we still have critical opportunities such as the West Elk mine in Gunnison County. So quick summary of kind of where we are and where we need to go, and I know I'm running out of time, so I may borrow an extra minute or so, but we are in a unique place where I think between the governor and the legislature, we have the best support for Clean Air Act initiatives and clean air initiatives than we've had in decades. And it's a historic time. We have new legislation and new tools, new directions to get there. We have the legal authorities to get there. I will say one area which happy to talk about during the discussion portion is that some of the provisions that have been put into the air quality rules and statutes for years by the legislature to keep us from moving quickly are still there. We still have to provide a very detailed record and legislative package for every rule that we pass, requiring us to quantify emissions reductions, cost effectiveness, and all those things. That requires research, that requires data, and so one of the questions is how we do that so we can pick up the tempo of that activity. And that really brings us back to questions of resources and the constraints imposed by Tabor. The Air Pollution Control Division has been kept exceptionally lean for years, even while the magnitude of the problem has increased. Federal contributions have either stayed stagnant or decreased. We haven't seen the big contributions for really groundbreaking work that was done in Frappe and some of the other kind of aerial surveys that were done. And the quality and usefulness of that data is limited by the fact that it hasn't been continued. We need both the geographic coverage, but we also need the temporal coverage so that we understand trends and really can understand the kind of micro scale distinctions which make a difference here on the end. Unfortunately, we did not receive additional resources for ozone or oil and gas issues in last year's budget. We're working with the legislature to rectify that right now. A critical part of that in the budget that the governor submitted to the legislature would be our request to double our funding and staffing for our oil and gas unit at the Air Pollution Control Division. That's everything from planning through permitting, through inspections, and all the way through to enforcement. We need to do that work. In addition, the governor has asked for additional funding to do some of the basic science I think that we need to do. So there were references in some of the presentations to mobile monitoring vans. We're asking for 2 of those, as well as staffing and a toxicologist to help us work through the interpretation of that information. One of the challenges, and Dr. Petrone showed some of the data from that produced water facility that was identified by a mobile van there at Wyoming. We are trying to drill into that issue, but we've been badly slowed down by the fact that we just don't have the monitoring tools or the staff to do that. That's one of the holes that we want to fill so that we can respond adequately, and that could be an enforcement action, it could be voluntary action, and ultimately, hopefully, a rulemaking package to fill in those holes, both on inventories, but most importantly, on actually how you do the rulemaking to reduce those emissions and make sure that we're making rapid progress to protect public health. And then finally, having conversations with the legislature, can't go into detail now about how we create a bigger, longer-term commitment to the basic science and research that we need, both in terms of tools, but also funding and staff to be able to have that sort of engagement that I think Dr. Petrone was calling for. We agree with that. And so, that's a place where I think we need to fill the gap, both that we've had here historically, but unfortunately that we have from the federal level as well. Very quickly, and last point, and happy to go, if I could get this to move. What's the role of local public health in this process? First, and critically, as you know, we're undertaking a 5-year update right now of the public health plan. That's actually going to include climate and air quality considerations in there as well, I think much more than in previous years. And so, there will be a map for our efforts, our accountability on that front, and really have appreciated the really great input from local public health authorities on that front. Next, the kind of role of data and the collection of data is critical. Much of the work up at Boulder Reservoir that Dr. Helmig referred to is really happening because Boulder County has stepped up City of Longmont have stepped up to supplement the resources that we have, and we certainly welcome that. City of Broomfield has either required or done considerable research on emissions and concentrations from the oil and gas industry. We welcome that work. One of the things that we want to do is better integrate some of that data along with data from federal government and others so that we can try to get there. It's a challenge with IT and budget considerations, but that shouldn't be an excuse. We need the information. We need to better use that information. And we are in conversations about how we can better standardize the approach. We're having conversations with Broomfield about that right now in how we handle things like health effect complaints associated with oil and gas and how we can coordinate response on that. And then finally, at a local level, I think local government is particularly well suited to handle a lot of the issues that we're facing right now. Many local governments, including a number I see in this room, currently have greenhouse gas and sustainability plans. Those pave the way by creating data, by providing examples that we can then use to create the rulemaking packages to roll out on a statewide level, as well as make quicker progress than is often possible at a state level. But local government is right at the heart of those two biggest sectors on greenhouse gases, which, by the way, are also critical for ozone. And that's the built environment, the kind of system of transportation, land use, to what extent are we sprawling, to what extent are we driving, VMT. Those are driven by decisions that are made at the local level, and therefore much of the progress or lack of progress will happen at the local level on that. Transportation-related decisions, investment in transit, decisions on density versus sprawl, all of those things happen at your level. Local public health, I think, has a critical role to play in reinforcing what it means both on a statewide basis, but also on a very personal and intimate basis on a local level, what it will mean for air quality, but also active transportation, the effects that it has on obesity, cardiovascular, respiratory, and other health. So with that, I look forward to your questions. Again, I do have to duck out a little bit earlier, so if you have questions for me, try to front load them, and I appreciate everybody's engagement on this critical issue. Thank you.
All right, so our final speaker is Dr. Brenda Eckwurzel, a senior climate scientist and director of climate science for the Climate and Energy Program at the Union of Concerned Scientists in Washington, D.C. She will help link what we've already heard about ozone and climate back to public health. So welcome, Dr. Eckwurzel.
Thank you. So thank you, Dr. Crook, and especially Dr. Helmig and Putnam and Petrone. Everyone, they gave us some sobering data. Let's just stand up and give a stretch. And whew, wow. Seriously, if you want to, you're welcome while I call up the first slide here. So, Bill, I just do the green arrow, right? All right. So, essentially, we learned that, as my colleague told us, Dr. Helmig, that weather and the patterns really determine the air quality given fixed sources and mobile sources in the state. And what I want to talk to you is do a transition to how is that perhaps changing with climate change. So I'll talk about how that factor, what we call the climate penalty on ozone and other air quality issues, and the climate penalty on other health issues that are around the state and indeed the region. So I want to do a transition to that shortly, by first grounding us on the path that we are now on. Is the black line, since pre-industrial areas, we have globally a 1 degree Celsius dangerous world that we're currently living in. And you can see that, given the data, that we're on, this is the 4th National Climate Assessment, that red high emissions pathway, which was put us way beyond the Paris Climate Agreement by the end of the century guardrail. So if you want to do a low emissions pathway, we'll talk about the difference between the red and that sort of middle line. And a lot of the figures I'm going to show you And the Paris Agreement is really the lowest line to try to get us. So we have to be turning this curve around real soon. And the reason I use fossil fuel as the primary driver of this in the vertical axis, because these emissions are largely determining the global mean surface temperature, which is the metric that the international countries got together in Paris in 2015 and said, let's do this. So, thank you so much for, there is a long delay on this. Where should I be pointing this thing right here? Okay. Okay. Let's see where we've gone in the Southwest, and you look at Colorado, the northeast corner of that figure. What you'll see is that the difference between the 1986 to 2016 period compared to the 1901 to 1960 average is increase in temperature. And you can see the change in temperature in degrees Fahrenheit from that local location. You have globally, we have a global 1 degree Celsius, which is about 1.8 degrees Fahrenheit. So think about that in that horizontal axis. Many places in California, Western Colorado are way above that global average. You guys are warming faster. So a lot of public health experts in this room definitely know this, but it's good to remember that what is the heat index? At Union of Concerned Scientists, we did a report that's down there at the bottom, and the peer-reviewed published paper you can get by going to that URL and get some of the data I'm just going to show you. But just to remind everyone, we look at the heat index of 90 degrees Fahrenheit because if you're an outdoor worker, or you're exposed, you're doing activities, this is a threshold that's really critical in this sector. Another sector is above 100 degrees Fahrenheit. If you have pre-existing health conditions, you're elderly, this can become a very uncomfortable heat index that is unhealthy. Now, all of us, if it's a heat index above 105 degrees Fahrenheit, if you're out there doing an activity, you're likely going to feel it, and there's going to be consequences. The other thing we found in the report that the National Weather Service, above a certain temperature threshold for heat index, just don't calculate it. And the places in the US that currently are above, that are off the charts, are the Mojave Desert, the Sonoran Desert. And what we found is with future climate change on the high emissions pathway, there are a lot of places in the US that are they're off the charts, basically. So we also point that out. We kept track of that with our team. And as Dr. Crooks knows, there's lots of health consequences with extreme heat. Some of them are direct, and some of them can exacerbate pre-existing conditions that might be your individual health profile. So let's get right down to it. These are the results from our study working with Abatsaglu, who worked with the National Climate Assessment, doing regional downscale models at a high resolution for the United States. And we asked them, let's put it in the National Weather Service heat index values. So these are heat index values. If we did the late century high emissions pathway, we didn't take action, Colorado looks kind of hot. Your number of days, you could be over 2 months of over 90 degrees Fahrenheit heat index in a lot of part of the state. A lot of people are going to be running around in this country and trying to come to Colorado mountains and saying, help, can we escape this? So get prepared for your mountain communities. But if you do late rapid action, Colorado can do much better. But the difference is that in the no action, about 3.9 million people will be exposed to this heat index. But you can reduce that a lot by going rapid action, which is the middle curve I showed you in that prior temperature graph. So what does this really mean? Let's look at Denver. I mean, that's a big contiguous US map. What does this mean? Here are the results from our study. Historically, in Denver, you have between 1971 and 2000, about 5 days per year, the heat index got to 90 degrees Fahrenheit. Yeah, turn up the AC, stay inside, go put on the fan. By mid-century, under a high emissions pathway, you're over a month. Now, those might not all be consecutive days, but over a summer season, 40 days, over 90 degrees Fahrenheit. Remember, outdoor work, lost labor hours. Late century, you're definitely over 2 months above 90 degrees Fahrenheit here in Denver, around 76. But with bold action, we could reduce that to 31. And as Gabby Petrone, Dr. Petrone said, even if we do bold action, we're going from 5 days up to 31. So the inertia within the system, we are hurtling towards the Paris Climate Agreement guardrails. So let's look at 100 degrees Fahrenheit. The good news is that if you did bold action, you could probably save and reduce the exposure for about 270,000 people living in the eastern part of Colorado that would be exposed to above 100 degrees Fahrenheit heat index. But if you did the bold action, pretty much you're clear. You're protecting them. They wouldn't be experiencing this. So it's really important to reduce the emissions. And the reason I want to also go for, in Chapter 29 of the Fourth National Climate Assessment, I had the pleasure of being one of the co-authors of this chapter. You will see a table that the second highest cost for loss and damages for the contiguous U.S. is extreme heat mortality. It is over $150 billion average annual costs to the United States if we do that high emissions pathway. Now, that's an average. It's around $87 billion dollars in the year 2090 to about $200 billion, but let's average it. It's well over $100 billion. But if we don't go on the high emissions pathway and we did the 4.5, which is that middle line, RCP 4.5, a lower emissions pathway, we could reduce those damages to the contiguous U.S. and our economy by nearly 60%. How do you get the rest of that pie? You got to educate your population. You need public health officials. You need cooling centers. You need to protect. You need to adapt. The rest of that pie is adaptation. Okay, so the top cost in the United States that we have in that chapter, and I'll show you the full table. It's a lot of numbers, but I'm just showing the top two, is lost labor hours. Similar numbers to, but it's a little bit higher than extreme heat mortality. It's around 80 to about $200 billion on average in the year 2090. Every year, we're hitting our economy. Why is that? People working outside, protective services, security, construction, they're exposed to this heat certain times of year, and we lose labor hours. Now, the average is well over $100 billion per year, but we could reduce on the lower emissions pathway, RCP 4.5, nearly a half. The rest of that, we're going to adapt. So we got our work ahead of us. We have to plan, prepare. Best of all, let's avoid this. Okay, we learned from Dr. Helmig and others 3 ingredients for ground level ozone. You got your point sources of VOCs and NOx, plus the heat, plus the sunlight. What's changing with the climate? The solar, solar cycle is about the same throughout the year. Each day it's changing at this latitude, it's summer and winter, but the heat, that is what is changing. Also, if we don't have these sources, so the numbers I'm going to show you from the National Climate Assessment are assuming that we continue at this level of having point sources of precursor emissions. So the point is that if you have further climate change, it gets harder to stay within attainment. And so I'm just repeating what Dr. Helmig says. By mid-century is the top level, 2090 is the lower two, and the lower scenario is on the left, the higher scenario is on the right, and you'll see that Colorado would have a harder time to get every few parts per billion extra of ozone. But that's just the general concept. And remember, these standards may go down, as Dr. Putnam said. The federal standards are not really what the World Health Organization says we should be doing. So likely standards will go down over the years as we start getting off fossil fuels, and we're going to have trouble. We'll have that climate penalty from the extra heat. And now, I took this picture while we were here in April, looking at some of the point sources in this region, and reminding us that the people living close to it really have health impacts from this ground level ozone. And obviously, depending on the prevailing winds, as Dr. Helmig has showed us, when the winds are right and the winds are bringing, are blowing this stuff away from the point sources out of the region, then you got your clean air days. But when it's a different weather pattern, the local residents and the Front Range communities are being exposed to this ozone way above what probably the World Health Organization says is okay. So we know enough to start acting, and we do need more observations for sure, because it's a complex region here, and we need to understand these dynamics. So I would argue for a lot more data and observations, and let's transition the mobile sources so they're not a source. Let's get electric vehicles from renewables so your point sources are going away. If you reduce the NOx, reduce the VOCs, reduce the VOCs, basically, and you reduce the temperature, we keep global warming not as high, you can get ahead of this, and we could start really protecting communities. So let's transition to some other health effects, move away from ozone. Here's a person, he is putting his lives on the line during the Boulder Canyon fire. He has a direct health risk. He's also experiencing extreme heat, and he's also breathing really bad air. It just symbolizes the consequences of wildfires. And unfortunately, climate is influencing this as well. In the fourth National Climate Assessment, this figure is basically the cumulative forest area burn is increasing on the vertical axis, and you're going from around the late 1985, or about 1985 to 2015 in this graph. The point is that in the year 2015, nearly half the cumulative acres burned by 2015 would not have happened were it not for this 1 degree Celsius dangerous world that we've embarked upon over this time period. So climate change dries out the soils, increases the evaporation. Basically, a warmer atmosphere is, as Deke Arndt said from NOAA, it's a thirsty atmosphere. It sucks up the water from the vegetation. You have water loss. You're drying out your forests. And when there is a lightning strike or an unnatural source, a spark that's human-caused in the wildland-urban interface, boom. Unfortunately, these fires are really hard to get a hold of, and they have public health consequences that are indeed severe. So in the High Park fire, we found that Fort Collins experienced really bad air quality. And this type of thing is happening more and more in the country, and Colorado is not exempt from this. And unfortunately, this is throwing carbon that has been sequestered in trees for a long time into the atmosphere. So that is, contributes to the climate change problem, but also it has lots of health, and it's a drain on resources, and we have to get better about preparing, planning, and having better practices for this, protecting communities and figuring out how can we manage these forest ecosystems better. Another thing is, a lot of people aren't as aware, not all elevations are experiencing the pine bark beetle outbreak, but many people are very familiar with the types of trees and which elevations are most at risk of this within the Colorado region. And then if a fire comes through, these are the ones that will be like kindling in the fire. And then after a fire, you might have some precipitation coming through, and you have post-wildfire flooding, and the extra organic debris that's coming down these slopes. Some of them are overwhelming water quality systems and downscale communities, and the organic materials are creating compounds that are, contribute to cancer. And so that means the water treatment facility that's local may not be causing the global problem. Their budgets could be overwhelmed with trying to protect their local community, their local water supply, from things that the EPA will say, wait a minute, that's cancer causing. You can't serve this water unless you clean it up. Costs are going up. All of these. We have hot shots fighting these fires. We have water quality issues, costs. And as Dr. Putnam said, these costs are flatlined. How do we go? How do we get on top of these accelerating costs with this climate penalty? Another issue is with the post-wildfire flooding or just regular old extreme precipitation, that there's more likely when it rains, it can be an extreme event. Even in areas that don't have wildfire, you're seeing massive cases of extreme precipitation that might cause a direct threat to life, direct harm or injury. And then there's the soil saturated, the saturated soils in the US, we've had 12 months of incredibly, the highest since record keeping that NOAA has been keeping. And a lot of people's basements are they're having to deal with getting the humidity down and everything else, and that's mold and air quality, and also the water quality issues. If these streams are flowing into any areas that are dealing with water supply and water quality that people are also drinking, these can become a big issue. So it's these cascading consequences that climate change can be a little tipping point or an exacerbator that add up: more costs, more damages, more loss. So the other thing is, where are the losses occurring? Unfortunately, as people know in this room, it's an unequal burden that communities of color, older adults, children, low-income communities tend to be more on the front lines of the health impacts that are happening. So let's quickly, that is the graph, and see it filling in. Thank you, Bill. Oh, you're my star. The red ones I just highlighted, you don't have to, just go to chapter 29 in the Fourth National Climate Assessment released in 2018. The red boxes are the ones that are related to health. And the top 4, we're talking hundreds of billions of dollars, the health impacts from climate change by the year 2090. Let's avoid it. Get in the right column, the lower emissions. And we could go a lot better to protecting people's health. So fighting climate change improves people's health, bottom line. But who's going to pay for the cost? Who are going to pay for the losses? Who's paying for the damages? Who's paying for adaptation? Who's paying for planning? Well, people in this room know that essentially when there is a post-wildfire flooding after the Hyde Park fire and there's debris flow, it's the county maintaining the roads. Local officials, local municipalities, the counties, the state are bearing a lot of the brunt of these costs, and lots of times these are global forcing that is causing a lot of these changes, as well as Dr. Dekelev pointed out, and Dr. Petra, a lot of local forcing contributing to the global problem, but also contributing to bad air quality and other health impacts. So the United Nations got together in 2015 and said, well, look, some countries have contributed more to global mean surface temperature increase than others. They bear the responsibility. And others are saying, well, okay, that UN process, some countries that bear responsibility may not be contributing and doing their fair share to that international process. Maybe there are also some other actors that could be pulled into this, not just the UN process, but looking at which human activities that happen within these countries are contributing the most. And that's the extraction of fossil fuels and cement manufacture, and the sale of the product for use as energy contribute to the problem in the biggest way. So some people are saying, where's the role of their fair share of responsibility? And what we see is that we wanted to know, what did the public think? And so we partnered with and asked the esteemed Yale program on climate communications to do an independent poll. They're the experts in this, but to ask some questions we wanted them to ask. And I'm going to share with you some results from Colorado. Here we go. So here is the first question. 57% of Colorado adults think fossil fuel companies are responsible for global warming damages. 56% of Colorado adults support fossil fuel companies paying for global warming damages. And you'll see that there's a lot of other states that have similar, similar colors to this. And we have to really close because Dr. Crooks is going to take me off the stage. And I just want to say that you might be surprised that they think that fossil fuel companies should be contributing to some of these damages, because what we see is local communities are overwhelmed. The budgets are being, the damages could blow through a budget that might be a year, take 3 years of an annual budget for a local municipality to deal with even one of these extreme events. And so these extreme events are adding up. How can we come together, which is are tasked to better protect communities and their health and their well-being. And what gives me hope is that so many of you who are decision makers in this and play a role are thinking about these intersections of these complex issues and how we can better protect communities. And so I really appreciate the discussion that's going to happen afterwards, and I really look forward to your questions. Thank you so much.
All right, so next we're going to move on to the Q&A portion of the event, but we're actually kind of ahead of schedule. So why don't you stand up and move around for about 30 seconds. And there we go. And I'll invite the 4 speakers to come up and take a seat.
Thanks for seeing.
Yeah, no problem.
So, good to meet you.
Yeah, it's good to meet you in person finally. Yeah. And then we talked on the phone like over the summer.
We did. I'm over there every other couple weeks getting Xolair, so I have
Oh,
great
really?
respect for the institution.
Oh, that's great.
and,
You really must have some serious asthma issues.
I had childhood that kind of went down, and then the last couple of years, actually 2018 killed me.
Yeah.
So it was big.
Yeah, it's weird.
One of the big reasons I took this job, actually. So
Yeah, I never had allergies until I was like 38. And then I started getting like this tree allergies in the spring. I was like, what is going on here? It's the weirdest thing. Fortunately, mine's pretty easy to control. It's still like a surprise.
it's still a thing.
Yeah, it's like this should have happened already.
It makes a difference.
Turn this on.
Dr. Gerber.
Hey, Jason.
Right.
Test. Check.
Your expertise, energy.
Test.
Hoping once he's done, I might be able to replace him.
Test.
That would be, I think that would be really interesting. I know he's reapplying this year, and I don't want to compete with him. He's a really good guy.
Well, and there's not quite as hard, but traditionally having 2 terms, and he's had his 2 terms, so it's up to the governor's office, but we're getting more pushback on reappointment. Our hope had been to reappoint everybody, so we may not get there with the governor's office because fresh people. So I certainly encourage you to throw in your hat for years in the future. We're kind of deep in this, and happy to set up a time with Tricia Oath. She's the administrator for our AQCC, and so takes the lead point running hearings and working with commissioners and helping win choices for the
Test.
commission. So let's definitely bring some time
Next year.
set you guys up. So,
Test.
I mean, Tony's been so good.
Yeah.
It's just the questions and the public health focus and research-based focus that he brings to it is
He's very encouraging.
That's such a great question. So AQCC is regulatory. RAQC is planning. So they're supposed to come up with plans for compliance but they don't actually doesn't have legal authority to regulate. It makes recommendations and that is the AQCC. So that's the kind of main difference between they do. So a number of us from the department sit on the rack. They talk to us, we talk to the staff. At some point, we can we changed chairs and we changed executive directors.
Test.
Last year, so kind of in the process of freshening things up and that sort of thing. And some of the chief so as well. At the end of the day, we need to refocus RAC as a and I mean, I think, and it's one of those things where we on one hand, I see some evidence on health effects and the release of the standards. Safety is probably and yet, from a control perspective, just based on what flows into the state and the natural background in this environment, I'm not sure how we do that. So, what are the consequences for doing that, which I think is what which is both improper and I understand all at the same time. But yeah, I want to always keep an eye on not just what our current standards are, but thinking ahead, and especially for the I've spent my whole career working in ozone, but at the same time, actually, that's probably more important from a perspective.
Yeah, one thing having worked with the nuclear as a scientist, it's really struck by the fact that the clean arena just doesn't have equipment, to do climate change. And it just isn't sure.
No, it wasn't written to do that.
It has, has the authority to endangerment findings and stuff, but make some research into this job. There needs to be something new to protect the climate change, air pollution that comes from it, naturally occurring storm force, but so just focusing on I'm missing 2/3 of the story.
And then that brings us back to failing to
Like a microphone.
fear.
I don't think you can. Well, you may be able to with the turnaround.
And it goes backwards.
Right, yeah, no.
Yeah, but you need the
Tough place.
Like I kind of
microphone. The microphone jack. That's the headphone. I don't know. Okay. Taking it through the speakers.
Add, subtract.
We'll just have to go. Okay.
Well, so is there any,
So I'm just gonna put it back on.
I have some
built-in,
questions that
Okay.
Unless we can rig this real quick.
Unless we could do what?
made a lot of good ones.
So if I put a
If there's something else.
XLR to MIDI,
I think one would be how the public and local public health engages in some of the rulemakings. Other initiatives that we're talking about. Since I shortchanged that part a little bit.
Yeah, sorry, I was moving over you.
No, it's fine. I was trying to put the 50 pounds in the 20-pound bag. It doesn't always
so I was
fit
just gonna take this
well.
off.
Not always edifying the way.
But you can't go into that headphone jack. That's an output.
There's a microphone.
All right, so what time do you have?
No, I bought a tiny bit of time.
There's
So
no microphone jack.
11:30. So I've got
Alright,
somebody else
so-
to get started over at the Transportation Commission.
Not getting it through the HDMI. That's what she was trying to do originally.
Well, it was working earlier.
Yeah, originally I was just going to have questions just for you.
But when I put it on 4K,
And you can't close that down.
But it's definitely
That's
probably
right.
a little bit more focused than
Yeah, no, that makes sense. Yeah, I have this opportunity. And do get work with the agencies.
Yeah.
You know, right now, but
I have one.
the funding and we'll set up traffic Tricia. Just as part of bringing the other thing we're having conversations with Senator Fenberg, who was here, but disappeared about, and I neglected to give him a call out, which is my failure for working on a bond grant. We're talking about doing more of a psychological role as well, which at one point we had and we moved back on as a state. So we're going to
way you build it, look at what is going wrong with the advisory committees that the usually have.
Yeah.
Try to bulletproof it from both sides.
Well, and that's part of the challenge we have is trying to not just do what fits in our current system, but what happens if we have a different governor, if we have a different legislature, and trying to create institutions that work kind of in both ways. That becomes a longer joke, or just active interference, which is controls efforts too that they actively subvert good science, which is sadly a real possibility. So, other than that, it's all great.
Yeah, right. Yeah, everything's fine.
So,
Then I'll
yeah.
go home.
Can I get a card? Because I have two questions that I don't want to burden this with.
Yeah.
And they are technical, I just am afraid they take too long to answer. So
Yeah, they're in my bag. Let me grab one for
Okay.
you. So,
I'm ready for what coming.
Test. Test. Test.
All right, folks, I think we're going to reconvene, so please take your seats. And the four speakers, I invite you back up on stage. Please take a seat here. Brenda? Dr. Eckwertzel, is she around? Oh, there she is. Okay, great. Yes.
Yes.
I'm just gonna there.
Is that your coffee?
Thank you.
All right.
I might do a quick shout out to Senator Petra.
Come on, tap your mics and make sure this works. All right, so now we will start the Q&A portion of today's event. To facilitate the questions from the audience here in person, Susie and Bill are going to be roaming about with microphones. So when we get to the open floor, when I open the floor for questions, please raise your hand and they will come to you. Please, as Mr. Putnam told us earlier, he has to leave a little bit early. So please, if you have questions for him, raise your hand early and eagerly, and we'll try to get to you first. We have a lot of people attending remotely, and we really appreciate having you here. Unfortunately, we will only be able to take questions from people in the room, and I know that there may be some issues hearing the speakers' answers online, so we apologize if there's any interference there. And finally, when we do open the floor to questions, if you are asking a question, make sure it is, in fact, a question, ending in a question mark. And please be concise, just out of consideration for all of the other speakers, or all the speakers and the other people who want to ask questions. So I'm going to start off with, we good? Okay. With a question for Mr. Putnam. So actually, I'll have two questions for you. First, as we said, the EPA recently downgraded the Front Range from moderate to serious non-attainment of the ozone standard. And in a pretty unusual move, the state supported that downgrading. And so I'm curious, what is the benefit to being downgraded that the governor saw?
Sure. And before I directly address that question, just wanted to, my brain's on Beijing time since I flew in late last night, and wanted to do a quick call out to a couple folks, I think, to reinforce just how important this issue is for the state. Majority Leader Fenberg is here, and I think his presence and leadership last session is one of the reasons why we're making progress and having focus on this. My executive director, Jill Ryan, was here. She had to run out this morning as well, but I think the focus on those issues is particularly important at a high level. The governor's identified air quality and climate as one of the top 4 bold goals of the state, and reflecting that, I think, in terms of how we use our political and other capital, and we want to make good use of that. And then many of you have probably not had an opportunity to meet our climate unit director at the Air Pollution Control Division. That's a position we just started in the last few weeks and have spooled up a climate unit. Clay Clark is our inaugural person. He's a good person to know because he will be leading some of the sessions and leading the division's process to come up with the inventory and other pieces for greenhouse gases. So to go back to your question on the ozone non-attainment, I think the primary benefits of a downgrade, and it's a double-edged sword because it requires more engagement and lack of flexibility with EPA, which by itself is a double-edged sword. But the primary air quality benefit for a downgrade from moderate to serious is that it reduces the threshold for permitting of major sources, as well as review of federal projects under the so-called conformity rules from 100 tons per year to 50 tons a year for VOCs and NOx. And so one of the things that will do, and we'll see the final numbers when they come in, but increase the number of sources that need to get a major source permit as opposed to a minor source permit by hundreds of sources. And so that is good news because it reduces that threshold, imposes some additional requirements under both Colorado law and state law. The flip side is that's hundreds of additional permits that we have to make sure that we can get staffed and actually make sure that we're doing the enforcement. So that's a big focus for the legislative ask that we're looking at to double the size of our oil and gas unit so that we'll actually have the people power to be able to do that. And for example, we'd like to double the number of inspections that we do, source to source, so that we'll be able to have more eyes out there, more technology, et cetera. There's some other details related to fuels and other sort of things, but the big one is really that change in threshold.
Great, thank you. And so what can local governments and public health agencies do to get involved in the rulemaking that is being initiated this year?
It's a great question. So under Colorado state law, we need to develop a robust record before we can change the rules for any source, especially when we move past a federal standard or stricter. The law requires a kind of higher bar for us from a data and information perspective. Your experience, your views, your information, as well as your political support, help our efforts in doing that. So, providing information about local public health, providing additional information from the perspective of air quality monitoring, to the extent that you have information from inspections, a number of facilities, Boulder County being one of them, Broomfield being another, Garfield being another, do inspect sources, do have optical camera or infrared cameras. All of those sources of data are helpful to us as we develop those rules. And, we're going to have a very busy tempo, and the Air Quality Control Commission is going to be busier than it ever has been. They need to be reminded about the local public health stakes of everything that they're doing. It's easy to get lost in the minutiae of how many inspections per year you should be doing in the Piceance Basin. They need to be reminded why it matters, what the practical effects are on local public health, how local governments can be partners in that process, and we really value the engagement from local public health, from general purpose governments, as well as the general public. We've tried some new things in the last year, including workshops to help better educate the public on how to engage in the complicated Byzantine process we have under Colorado state law for rulemaking. And we had really good feedback. I hope that we're able to do that again. And there are more remote sessions, evening sessions, sessions outside of Glendale. As much as we all love going to Glendale, it's hard for people to do during the day. So we hope that people are able to take advantage of that.
Great, thank you, John. I have a question now for Gabby and Detlev. So what do you think the state can and should do in order to improve the monitoring of the VOCs and the ozone?
So the question was what the state could do to improve the monitoring of VOCs and ozone. There's two different questions. In respect to the ozone monitoring, let me start with the easier part of the question. I think the state is maintaining a pretty impressive network of ozone monitoring already at this point. One of the maps I showed available ozone data within the state, and there's 80 places where ozone has been monitored in the state of Colorado, and probably, I'm just guessing, a third or half of them are monitoring stations maintained by the state. Just here in the Front Range, there's probably some 15, 20 sites right now that monitor ozone. So overall, that's a pretty good coverage. And ozone is a regional pollutant that develops over hours in the summer, so it mixes around. So I don't see the necessity to have very high spatial resolution in ozone monitoring. However, there is a gap. There is a gap which I would define north of Denver, east of Fort Collins, east of Loveland, that area. There's only one or two sites in that area that we've identified as a very significant, strong ozone precursor region, which is the oil and gas basin. So I think that area is covered quite poorly at this point. So I would encourage to deploy several more sites within that region and also possibly upwind of that region. So that's the situation on ozone. Now, for the second part of the questions, VOCs, it's a totally different topic. At this point, the state is actually not maintaining a single continuous VOC monitoring program. The state is operating canister sampling program at 2 locations, one in Platteville, one here in downtown Denver, but it collects only 1 sample every 6 days in the mornings, and the value of the program and the information and quality we've gotten out of that has raised a few questions recently. So the state at this point is not conducting, to the best of my knowledge, any continuous VOC monitoring. So Boulder County stepped up, and they've been supporting us to implement this VOC monitoring at the Boulder Reservoir, and that's continuous. It's high time resolution every 90 minutes. It's public data. And I think we've all seen the value of that data, and there's certainly neat desire to implement and operate more of this continuous VOC monitoring. There's a little bit of good news because the city of Longmont has provided funding to start a VOC monitoring program at the Union Reservoir. That's probably going to start just in a week or 2 from now. And also Broomfield has stepped up and has provided support for 2 VOC monitoring stations. Also, they will be continuous at high time resolution. So within the next few months, there'll actually be 4 stations that will be reporting VOCs. So that's a huge step forward from where we were 3 years ago. But if you look at a map, those now will all be pretty much in one pocket of the state, you know, between Broomfield and Longmont and the Boulder Reservoir. So we still lack observational capabilities in the entire remainder of the states. And we know that the oil and gas industry is very, very strong. Actually the by far strongest source of VOCs within the state. And at this point, we don't have a single continuous operating VOC monitoring site within the center of Boulder County, I would call it. There's no continuous monitoring within the urban area in Denver. It'd be of value to have monitoring upwind of the region so that we can better analyze the data and understand what's coming into the state and how much is being added from regional emissions.
Okay, well, Gabby, it sounded like you had some thoughts on that too, so can you give us the highlights?
Yes, and I'll try to be quicker. I think we need to take more questions, right? So we need more ozone sensors in the oil and gas field, number 1. There's no question about that. For emissions, we need to understand the mix, and that's what Detlef and ambient air monitoring does, but we need to do a much better job at understanding and quantifying the emissions themselves. And there's a lot of research that has been done on that. It needs to be coordinated for the bottom up, that's what the state or EPA does, and the top down. And we've done research, I can give contacts and papers on this kind of reconciliation work. And that takes resources, but it can be done, and it costs maybe $1 or $2 million, but it can be done very effectively, and you can move forward having much more confidence that your tools, your bottom-up tools, are close to being accurate. So I think the research portion to understand these emissions, and later on we can talk about impacts. I know there are some people interested about the impacts of the emissions, but the emissions themselves need to be quantified a lot better, and I think we need to leverage federal resources because the EPA is not providing the right tools to the states. And they have to invest. The EPA lost much of its research capacity many years ago. But they need maybe to contract out or to work with researchers who can help them provide much better tools designed to help states manage their air quality and their greenhouse gas emissions.
Great, so I'll ask.
Can I just add one point?
Sure.
Gabi mentioned it, but I want to emphasize this more. Measuring concentrations and determining emissions are actually 2 different things. And very often we see these terms being mixed around and not very well defined. Monitoring concentrations is relatively easy. Well, it's easier than determining emissions. So even with implementing sites that monitor concentrations, we're not immediately defining emissions better. So there's a research component that needs to be considered as well, so that these atmospheric monitoring data, concentration data, can be used and transformed into emission estimates. So there's a research component that needs to be considered in addition to a plain, simple monitoring program.
Okay, John, can you quickly respond?
Sure. Very quickly, I agree. I think with everything that's been said, we need more and better data across the platform, and especially to that point about differentiating between emissions and concentrations. One of the things that I think is most important to implement Senate Bill 181 related to oil and gas is, in order to meet state law requirements to have the robust record about emissions and costs, we need to understand exactly where those emissions are coming from, as well as having a big top-down. And that's a place where we have a gap. And so it's one of the reasons why we would like to invest in this mobile monitoring lab capability, along with other tools, at the end of the day, to kind of do the work that we want to do, fill in those gaps and fill in the gap from the EPA level. We need to find the resources to do that or take it from something else. And that, I think, is one of our challenges right now. We have been pulling from some other programs, but there's a limit to how far we can go, and I don't want to dig deeply into clean water, for example, or some of our other air programs. And so given that, and given the constraints of Tabor spending caps, then the real question is how to prioritize among this kind of suite of need, what's most critical for moving forward. I think right now, trying to understand those micro levels of emissions so that we can develop better rules and enforce them is our top priority. I think one of the things that means is we lose the macro ability to understand what it means regionally.
Okay, great.
If I can jump in, I would disagree. So we've done a very extensive reconciliation study that cost $4 million, funded by industry and DOE a couple years ago. And we did it at all scales. We had people on site, we had people at the fence line, we had people driving around, and we had an airplane. All that for $4 million, and we were able to do a bottom-up that matched the top-down. So, and we were able to understand where the emission inventory was missing sources, or where the emission strength per unit activity, the emission factors was wrong. So this can be done. It took 2 years of planning. And it took very stressful meetings, but in the end, having what I call a transdisciplinary approach. We had people from the industry there. We had Russ Snell, our deputy director at the time, sit there to really represent the government and the NOAA side engagement in bringing the best science to answer a big question that the government under Obama was interested in. How much methane is coming from oil and gas operations in the country? This can be done. It needs a real effort and buy-in from different stakeholders. But we cannot hide and just say it's never been done or we don't know how to do it. We know how to do it.
And just really...
I need to cut this off, I'm sorry. So we need to have time for the audience to have questions, but I want to get to Brenda first. So I wonder if you have a sense, in the absence of federal leadership, is there... the people who study this issue at a national scale, do you have a sense of kind of what are the best, most effective mitigation policies that state and local governments can put into place to help?
Well, I think that Colorado is leading the way, especially a few counties to the west of here, and a municipality. Maybe I shouldn't name the names, but what I want to say is that they're really forward-looking. They've done a lot to reduce emissions locally, a lot, even to like buying a fossil fuel producing point source, and that only gets you so far. You're gotten down to the bone, and yet you're still having extreme events. You're still needing monitoring. What do I hear up here? Resource constraints. What do I hear federally, nationally? There's another actor. So these counties and a municipality, 3 counties and a municipality, are entering into lawsuits that are saying, wait a minute, there's some fossil fuel companies that bear a share of this responsibility to help pay for monitoring, help pay for figuring out how do we adapt to these loss of damage, plan for it. And that is very forward thinking. And it's also waking up the nation nationally to it's not just sea level rise. Look at all the impacts that are listed in these lawsuits. So I think that there's some real forward-reaching thinking in this state of Colorado.
So do you feel like other state and local governments should be suing fossil fuel companies?
It's already happening. So
Yeah.
it's happening on coastal communities with sea level rise. It's happening with state AGs saying there was a fraud and misinformation lying to the public about the harms of the sale of a fossil fuel product for energy use. And there's a Pacific Coast Federation of Fishermen's Association. I may have got that name, the FFF's, which order they're in, but they are fishing for Dungeness crab and the warming waters, these heat waves in the ocean. 70% of the surface area of the Earth is ocean. So the global mean surface temperature, that's mostly the ocean. These heat waves are hurting our crabs, and their domoic acid it's a neurotoxin for human consumption. These fishermen are being told, you cannot do your livelihood, you're being shut down. People are their livelihoods of one livelihood, another livelihood is affecting their livelihood. And it goes on and on and on. So I think there are lots of lawsuits out there, and they're all looking at the federal, the policy, the state. Mitigation only gets you so far once you run up against these constraints that are put on local, state, and regional entities, which are very real.
All right, thank you, Brenda. I think now we will open the floor to further conversation. So yeah, people who want to ask John a question, raise your hand really, really high. But we have one to start with over here.
Hi, I'm Heidi Henkel. I'm a Broomfield City and County councilwoman, but I'm here on my own accord. I have some questions for Dr. Petrone and also Mr. Putnam before you leave. I'm coming off of Puerto Rico time, so I understand your brain right now. But I really want to impress upon you that our health data out of Broomfield is taking on its own qualities, and other states are now taking notice. So we have Pennsylvania asking for our data. It's becoming a big deal. We have health impacts of burning lungs, burning throats, burning eyes. We have kids gagging in their beds at night. This is a major health issue that we're having. We have air quality contractors not being let on site. That's an issue that we're having. We have release of chemicals in the drilling. We need to have release to our health department and also to our constituents' doctors, and that is not currently being released, but by the COGCC it needs to. So we're having a lot of conflicts here. We're also spending $5 million on oil and gas. We're losing millions of dollars actually on oil and gas exploration. One of my major questions here is, Dr. Petrone, you had talked about benzene, and I'll get to my question here in a little bit. We've had a lot of people have issues during the drilling phase, and they have this cocktail of chemicals, and we're detecting benzene. I'm curious as to, during those benzene studies, like what part of the drilling process was benzene the most high? And then also, Mr. Putnam, I kind of gave your toxicologist, I put her through the ringer during one of our city council meetings. And it's because, she mentioned that we only have 15% of the chemicals used in oil and gas that's really being tested. And then, we have a lot of air quality issues as well as a result. So my question is for Dr. Petrone, what are your ideas on testing for benzene and other issues or other toxins like toluene and xylene? And also for the CDPHE, are you willing to contract scientists to do these studies? Because I'm hearing a lot of financial constraints, but I would like to hear if you guys are willing to contract scientists to study this cocktail of chemicals that are affecting us, because benzene, if you hit the guideline, if you're still underneath the guideline, there's still financial feasibility into guidelines, but not standards. Guidelines are not, there's really no repercussions
I think
for guidelines.
we have the end of the question there. So please feel free to answer.
Go ahead.
Oh, me? Thank you for your question. I think it's important to get more studies done. We need to understand those sources better, and that will take someone with authority to go on site and take samples at the sources. Some of our composition data for emissions from oil and gas sources is from 2002. Hello? So we have a huge problem here. We didn't have the same level of activity at the time, and we didn't extract from the same formations, all right? So we need to have really a holistic view of these sources And that means going from what we put in the ground when we drill or frack to what's being extracted into different phases, and then where is the waste going and what could be emitted back then. So that needs to be done. With the funding we had, and only 1 year of funding, and Ingrid's time during the PhD, now she's graduated, but we could only study 2 sites in Greeley. One was the Triple Creek site, where they were in early production with huge amount of gas being flared, and that was a 90-day loophole that has been talked about in the press, and that the state is being addressing. And the other site was the Bella Romero School in Greeley, where our data is not public yet because we are finalizing the quality control and the analysis. We were at Bella Romero during the drilling phase, and we had several episodes of high benzene, but not just benzene. There's other stuff. So we measured all the BTEX. And I want to give a shout out to our data manager, who is John, right there in the room. You cannot collect huge amount of data because you don't collect just concentrations. You want the winds, you want the temperature. Without proper data management, you cannot do good data quality control and good data analysis. So resources are not just for a van or equipment for a van. You need scientists to look at the data, you need data managers, you need programmers, okay? And we are lucky at NOAA to have understood that a long time ago, and we have very strong database, skills thanks to people like John. I think the state, not just CDPHE, but COGCC and other agencies need to invest in this part of the question too.
All right, John?
And I agree with that. I think data management is a big challenge. Our air quality permit program is based on a mid-1990s platform, and for a variety of reasons, it's one of the hardest things to do is get that IT changed, even though it should be one of the easiest things. I think going back to the question, though, about core toxicology, again, this is a gap. Traditionally, the federal government would do a lot of that core toxicology and work their way through the different chemicals, provide standards, guidance, other sort of things that we can use as a state level. It's not happening at the speed that it once did, and we do have gaps in toxicology. So, we look at just short of 50 different chemical samples when we deploy the CAMEL, which we have in Broomfield and in Greeley, and the CAMEL is our mobile monitoring lab. We do have solid toxicology only on a subset of that. It's really hard to get that done just from one state's level. The amount of resource and science that has to go into that is daunting. It's especially daunting because we have one environmental toxicologist at CDPHE, and she's covering Rocky Flats, this issue, all of the Superfund sites, perfluorinated compounds in water, and the list goes on, vaping. And so one of the things that we're asking for in this legislature is to increase our toxicological capability. It still probably will fall well short of what would be ideal, but again, you start where you can to try to fill in those gaps on a priority basis. Would we be willing to contract out for additional work on that? Absolutely, if we had the resources to do that. I think that's true on toxicology. I think that's true on some of the surveys and monitoring and other sort of things. I think we're open to those concepts. We have great partners in the research community here in Colorado that if we had the resources, I think we could work out. Just as a point of comparison, compared to our one environmental toxicologist, Texas has 16, and I don't think of them usually in the vanguard of these issues. Minnesota, I think, has 38, and California has more than 100. This is kind of our starting point, and it limits what we can do. We want to fill in that gap to the extent that we can, and that's a big place, I think, just for the service that we provide for our local public health partners. They look to us for a lot of the leadership and capability on that. We have a limited supply to go around.
Great, thank you. Next question. First, I want to say, please be concise in your questions. We do need to get to a number of different people here. So, Do we have?
So I think he
Yeah,
gave me
okay.
the
You have the
microphone,
mic,
so I'm
so
going
it's your
with it.
turn.
My name is Barbara Millsbury. I'm with Be the Change. And my question just follows right along with what you said. Last year, over 2,000 wells were permitted. 1,000 of those, half of those, after 181 was signed into law. This year, already, 26 wells have been permitted. So as citizens, when we come to the rulemaking, and we ask, we're told, oh, no funds, we don't have this in our budget. It's like, and so as called for in 181, I believe the oil and gas companies could be required to pay for continuous monitoring, in effect, to be permitted to drill a well. And so couldn't we raise the money, if it's a Tabor issue, start an enterprise fund, coordinating with the academics in this room? Couldn't we have the oil and gas industry, not through suing them, but just as a part of their business, provide funding?
That's a great question. I think the answer is yes, we have to go through a process to do that. Some of that happens at a state legislative level. Some of it happens on a regulatory level. COGCC was given the ability to modify its fees. I know that's one of the things that it will be looking at. The Air Quality Control Commission was given the direction to look at continuous emissions monitoring for methane, and we can expand that beyond methane, and it's one of the things that we intend to look at in the rulemaking that we'll have this year. So I think the quick answer to your question is yes. For us to be able to exercise that authority, we have to build that record. So one of the things that we're doing is working with experts, working with environmental groups like EDF, local governments, and others to try to figure out what can we require that will pass muster so that we can make sure we do that. But at the end of the day, they need to be part of the solution so that we have more monitoring and more monitoring data. I think we still need an independent look from government to make sure we're comfortable with the numbers that are being produced on that front. And so, we need to put all the tools in the toolbox.
So who has?
May I add something?
Very quick.
Can it be a minute or two? Actually, I appreciate that question, and you actually provided some information. I've been wondering. I don't keep track of the permitting, how many permits and what they are. John Putnam earlier mentioned, in response to the question about the changes with the reclassification to a serious non-attainment area, that the permitting thresholds have dropped, and he brought in the number of 50, they're now 50 tons per year per major permit. 50 tons per year in VOCs. You have an idea what 50 tons of VOCs is? So if you see a big tanker truck drive by you to bring gasoline to the Phillips or whatever it is, that's about half of 50 tons. So you need about 2 of these tanker trucks to make 50 tons per year of VOC. So one of these permits, a major source permits, allows you to release 2 of these tanker trucks into the atmosphere over the course of the year. That's roughly equivalent to the emissions of 25,000 cars every year on the road. So driving cars with like 20,000 miles a year mileage, they release about as much as these 2 tanker trucks driving by, which is equivalent to one of these major source permits. So I'm a little bit surprised and a little bit shocked that I hear there are hundreds of these permits issued every year in a situation where we have a non-ozone attainment area. So I encourage you to do the math and challenge me, make sure I'm correct. Another calculations I did not too long ago is that last year, within the state of Colorado, there were about 8,000 electrical cars registered. 8,000 electrical cars. So the emission savings in the mass of VOCs of those cars are less than one single source permit, major source permit for VOCs. So one permit allowed, issued by the state, offsets all the emission savings that you have from all electrical cars that were registered last year in Colorado. So that's kind of the scale between the permits and other sources of emissions that we are more familiar with. So I appreciate your question.
All right, who had the next question? Looks like Caitlin.
Caitlin Rubley, I'm an emergency medicine physician. Just curious how we can better involve the health sector and health professionals in this, knowing that the health sector represents 10% of US greenhouse gas emissions, and many health professional societies actually recommend 60 ppb rather than 70, which is what we're trying to attain. Thank you.
Just really quickly, we found that when we did release our ozone report on climate penalty on air quality a while back, we brought health professionals, nurses, doctors in, to members of Congress, and it was amazing the impact showing up for those meetings, sharing your expertise at the local level, state level, and the federal level really makes a difference. We heard overwhelming concern being raised by listening to the nurses and doctors who really see this on the front lines.
John, you have a thought on that?
Yeah, very quickly, a few things. One, we need to hear that perspective, at the legislature in the rulemakings to kind of keep up the progress. EPA's decision to largely disregard some of the science on the particulate matter issue, as well as ozone, they recommended keeping the 70 part per billion standard, makes a difference. Political situation will change in DC, and so we need to kind of plan for that long game, as well as here at the state. But our Air Quality Control Commission does deeply care about the science, and they care about the health effects, and it's why they volunteer a lot of this time to work. One of Dr. Crooks's colleagues is a very valuable member, bringing a kind of pulmonologist perspective and research perspective to those industries. Beyond that, though, it is a big industry in Colorado. We've been managing issues with ethylene oxide, which is critical for sterilization of medical instruments. That's a place from an air toxics perspective that's kind of up there on the list. They've been responsive, but it's one that we need to keep working on. But then just day to day, a lot of the trips out on the road, a lot of the equipment is coming from that sector. So I think leadership from that sector in managing the vehicles miles that people traveled, converting to more of the alternative vehicles, those sorts of things, I think are critical pieces of leadership to help us solve a collective problem.
All right, who had the microphone next? All right, you, sir.
Great, thanks. This is a question for John. I'm John Douglas, Director of Tri-County Health Department. John, really two kind of legal questions. One is, can you paint us a picture, given the contribution of oil and gas to the ozone problem, and we're severely non-attainment, as to what steps can ultimately be taken to reduce emissions from that sector? I mean, is this, you painted us the picture, we've got to be careful, we have to build a case, but I'm wondering down the road when that case is built, what sort of regulatory approaches might that allow? And my second question is, you mentioned that we're sort of stuck with some go slow language in old statutes that's kind of slowing us down, and I'm wondering what opportunities there might be to revisit and revise that legislation.
Great questions. So very quickly on the first question, which is just what are our legal options available? Senate Bill 181 directed us to promulgate regulations to minimize emissions from this sector, but at the same time following all the procedural and other kind of rules that require us to have a kind of a heavy basis of data on emissions, on cost benefit, all those pieces. And so, I think we have a lot of authority to be able to drive through. At the end of the day, the core emissions on the VOCs are from releasing these materials from the ground or from the pipe into the atmosphere. Legally, we have lots of ability to try to keep it in the pipe. Technologically, I think we've made progress. We can make a lot more. And so a big part of the puzzle is just going to be how we keep moving, to keeping more of the product in the pipe, and then also addressing combustion emissions from all of the pumps and engines and turbines and other pieces, which we'll be focusing on later this year. Beyond that, I think there may be options to look at offset programs. There are offsets required as part of the major source permitting requirements to take a look at whether offsets may be appropriate in other contexts. There may be market-based measures, other sort of approaches. Those are the sort of things that are on the table that we need to look at, so long as we can build that record to be able to get to that point. And I think that's really the kind of core of where we want to move right now is how do we generate the information to be able to promulgate those rules that will survive scrutiny, knowing that we're sued on just about every one of the rules that we promulgate now. And we don't want to have a misstep so that we lose progress, that we lose momentum, which unfortunately has happened at the federal level. We've done well. We've survived almost all those legal challenges on a state level. We want to find that right balance of making as much forward momentum as we can while also making it defensible.
If I may, I think, I talked at length at the emissions and we need to quantify them. We need to be able to quantify the emissions reductions that the either voluntary or regulatory changes are bringing us. And that's one place where we have not done our homework. We have LDAR programs, we've had it since 2014. There's a lot of PDFs on the CDPHE website. You can go to tons and tons of material. Has it been digested in a way that we are learning from it? I don't think so. So there needs to be some very careful data analysis on data we already have from inspectors versus from the companies self-inspecting. All right? We need to understand where we are missing those emissions that we see when we do the measurements. And that starts with going with what we know and what we don't know. So I think that putting in the legislation, putting effort in policy making, but getting resources to evaluate the effectiveness of new policies is very important. And it has not been done at the national level or at the state level.
All right, I think we have time for maybe 2 more questions, so here's one.
Yes, my name is Wes Wilson, also from Be the Change. To follow up on Ms. Patron's most recent point there, that you have to monitor the effectiveness of your regulations. The question is to Mr. Putnam. Don't you think it would be far more efficient, rather than doubling your number of inspectors, you take advantage of companies like Scientific Aviation and mount that equipment on light aircraft? After all, they can inspect tens of thousands of sites per day and find these super emitters. Isn't that a far more efficient of your existing budget?
Thank you, Wes. I think that's a great question, and we're looking at those aerial options right now, and I'd like to generate funding to be able to do that, as well as to do the kind of comprehensive survey that Dr. Patron had requested. One of the things that we're looking at right now is how to do as many things with the tools that we get, and certainly the next tranche of tools that we can. Our sense is that the land-based approach is the next best thing that we can get, followed by aerial. So we're actually working with some satellite data we're trying to figure out how we can hone inspectors in based on satellite data to help find those super emitters. The super emitters appear to be one of the kind of missing sources that we have. So in addition to the leak detection and repair toughening that the Air Quality Control Commission just had, in addition to having the inspectors to do more of that work and the vans, there's a critical aerial and space component to that. At the end of the day, to have the effective program I think we need all of those tools. So I don't view them as either or. It's really a question of how do we get to a point where we have all the tools that we need to achieve the progress that I think the public expects, that the legislature expects, and that we need to protect public health.
Hi, my name is Christy Douglas. I'm just a concerned citizen from Commerce City. And my question is for you, John. Given this wealth of information that we've heard this morning, don't you think it'd be wise for the CDPHE to make a recommendation to the COGCC to pause the permits until we can get a grip on this?
So on that front, we have recommended a pause on certain permits where we thought it was close and there were unanswered health questions. From a bigger perspective, We are heavily focused on our own task from the legislature to develop and promulgate rules related to minimizing emissions from the sector. At the end of the day, that direction from the legislature was to minimize emissions from those sources, not stop or pause. And so is the approach that we're taking right now. I think the other place that we are working with COGCC is how do we speed up those rules? At the end of the day, we need those tougher rules that 181 required, and so we're putting the resources, working with some of my resources to help COGCC on the cumulative impacts rulemaking, on some of the other pieces that are needed to actually implement the direction from the legislature on that statute.
Great, thank you. I think we have time for one more question. Sir.
Yeah. My name's Phil Doe, and I'm with Be the Change, too. We loaded the conference. There's a logical disconnect here, it seems to me. Detlef's slides show that the VOCs are going up. The ozone is going up, and it's almost certainly attributable to the oil and gas industry. Yet at the same time, you approved 2,100 wells last year. You have a new law that requires you to reduce the greenhouse gas inventory in this state by 26% by 25. How are you going to do that, given the trajectory you're on with oil and gas development? Isn't this impossible? And I'd like for all of you to answer this, because I'm a citizen, I have grandchildren, and you're destroying the place I live. I'd like to know what the hell goes on here. It is impossible to do both of these things. You can't continue to raise the oil and gas production and lower the threats to the planet. You just can't do it. Please, John, explain that. Or the rest of you too, I'd like to know.
So I think that's exactly the challenge that we're working through. I'll note, I think initially, I don't think we agree that ozone is going up. On that front, our data from the extensive monitoring network shows that those peak values over time are going down. And a lot of that data ended in the kind of 2013, 2015 timeframe, and that was before a lot of the regulations that were in place. So at the end of the day, we need better science to be able to understand some of those areas. We need to invest in that science. But regardless of that science, we have a legislative direction to reduce the emissions and minimize emissions from those sources. That's our task. That's what we're moving forward to achieving. And it's going to require both addressing the source as well as the demand for those fuels. At the end of the day, we are consuming more fuel in the state of Colorado because we're driving more, we're buying bigger cars, and we need to address both the demand and the supply of those fuels, or we're going to not make those very aggressive greenhouse gas targets that the legislature laid out. I don't view failure as an option here. And so, I think we're deeply committed to working through those issues. That being said, I think the growth in the industry is one of the challenges that we have to deal with. We did not get a direction from the legislature to close down the industry. That's not a legal power that we have. We work within the delegated tools that we have from the legislature and do what we can within those constraints. And so we have taken our first step to reduce emissions through the rulemaking last month. We're following up with further rulemakings throughout this year and beyond this year to meet that very aggressive goal from the legislature. But I think going back to some of the data and presentations, we don't have a lot of time, and we have a really tough job ahead of us. All the tools have to be on the table. I can only use the ones that are legally provided to me.
Anyone else?
Yeah, I really thank you so much for your question. I did the calculations, and it's really quite high. We published a paper in 2018 that takes, working with colleagues at Oxford and also Rick Heady, he right here in Colorado, he went around the world, and all the self-reporting, as we know, may have some minimum numbers there by the companies from 1854 until 2010, and now we have numbers for 2015. And what we know is that these companies, about 90 of the largest ones, now about 88 given mergers today, over 57% of the ocean acidification traced back to just these 90 entities. More than half of the global mean surface temperature at the high end of the episode, 30 to 50. And about a third of the current level of global sea level rise, which is actually locked in, you know, there's legacy to that. And so it's very clear that the global mean surface temperature of the Earth and the Paris agreements, we are hurtling, as Gabby says, towards it because of these historic emissions. We know what the largest emitters are. We know where they are. And a lot of these companies are here in the state. And that is a fact. The ozone is also contributing, as Dr. Detlef said. And we know that when you clean this up, these air quality issues start going away. And so we're going to have a tipping point. We're going to transition. The consequence also of some of these emissions is that we're going to feel the heat much more, because some of those emissions, the particulate matter, some of the aerosols, the incomplete combustion of these fossil fuel products are keeping the Earth cooler than it would be without that. So we have a lot of planning to do for this transition as well. And drilling more wells is delaying, and there's a 67% chance to stay at the 1.5 degrees Celsius globally. We'll reach that at the 2017 burn rate in 8 years, 2028.
So I think we need to act as citizens here, not just scientists or policymakers or elected officials for a few years, right? So you need to vote, you need to spend your dollars where your brain tells you to spend it, but we need to educate people. The change we need is radical. I'm speaking for myself, I'm not representing NOAA or CU here. But please, educate your children, your grandchildren, and vote, and have the leadership you need to make the transition as bold as it needs to be, and as smart as it needs to be to maintain some of the needs we have and will continue to have. But we need people with vision. We don't have enough of them.
Right, thank you, and I'd like you to thank all of our panelists again. I need to finish up here. And thank you to John for staying longer than he thought he would be able to, so I really appreciate that. And you guys can have a seat. I'm going to finish up real quick here, so thank you all. Thank you. Yeah, thanks, John. Thank you so much. Come on. Should be one more.
You need to relaunch it. We'll have to get to it. I didn't know there was another one after this.
Is there not? There's supposed to be one more.
We'll have to navigate to it.
Sorry?
It'll take a while to navigate.
Oh, okay.
There was one last line.
Should be. I don't know that I got put on that. Actually, just put it on that one. Yeah, it's the same as that one.
If that will display.
Apologize for this technical difficulty. Great, thank you.
Yeah.
So as I mentioned at the top of this conversation, half of the babies born this year in the United States will celebrate New Year's Day in the year 2100. That's amazing. But it also assumes we don't mess up everything in the meantime. You know, that 950 part per million CO2, 4.3 degrees Celsius hothouse future of 2100 that Gabby and others showed us showed that we are barreling toward. That future is not science fiction. If we continue this business as usual thing that we are doing now, that future will happen, and it will happen to people alive today, people we know, people we care about. The physics guarantees it. There's no way to get around physics. But fortunately, we can change our business as usual. Now, we're going to do a little bit of audience participation here. How many of you have children in your life that you care about? It's a lot of you. I personally have 2 children. I have Charlie, who's 11, and Joey, who's 14. And according to the CDC, their life expectancy extends to 2080. By then, global CO2 levels will be roughly 3 times what they were. 3 times what they were when I was a baby. You know, my wife and I knew as soon as they were born that our lives were not about us anymore. Our lives were about them and about giving them the best lives that we could. And I'm sure all of you who are parents or guardians or uncles or aunts here feel the same way. You know, they became our purpose. So for their sake, we need to lift our eyes up from the news cycle, the election cycle, the legislative cycle, the budget cycle, the latest outrage on Twitter. We need to keep our focus on the future we are choosing for these kids, that we are forcing upon them without, you know, when they are too little to be able to say no. So one more show of hands. How many of you work for an organization that you feel like is doing enough to combat the climate crisis? That's actually more than I thought I would see. And this is kind of amazing that, you know, this is supposed to be a meeting of public health officials. Climate change will aggravate virtually every public health issue we work on today. It will amplify the crises we already face and add new crises on top. You know, if we don't stabilize our climate, little else we accomplish will endure. So we must be the voices of climate accountability within our organizations. We must be the voices that insist our organizations drastically cut their carbon footprints and to challenge others to do the same. We need to be the voices that demand that we take responsibility for the damage we are doing to our own kids' futures, not to mention the futures of all the kids around the world born in the climate crosshairs. The longer we wait to act, the more pain we are going to inflict on them. So we must have the courage to openly and forcefully talk about the climate emergency with people who don't care, you know, with people who have other priorities or people who absolutely disagree with us. There is no time left to be timid. We must stop treating climate change as a taboo subject. Measured polite silence, it didn't work for the HIV epidemic, and it's not going to work here. You know, people died because of silence back in the 80s, and people are dying today because of our silence now. Just look at what's happening in Australia this month. That's the price of silence. So we have to speak up. We have to use the words climate change, climate crisis, climate emergency. And we have to make it safe for those around us in our organizations to use them too. And we have to use those words not just once, but again and again and again until it feels real and urgent to our leaders and our colleagues. So after hearing today's presentations and listening to the panel discussion, if you're wondering what you can do about this climate crisis we face in your organization, there are probably a lot of things you can do, but here is my answer. Talk about it. Articulate how climate change will impact your community. Tell stories about it. Tell stories about it that are centered on health. Be informed, be passionate, be courageous, be hopeful. Find allies among us. Amplify their voices. Use what leverage you have. And above all, keep going. If you fail, keep trying. If you succeed, keep pushing. Because there is still so much good that we can do when we have the boldness to speak. So, now before we go off to lunch, I want to thank you one more time for attending this panel, and particularly those of you online who couldn't make it in person. And once again, I'd like to thank our generous hosts at Boulder County, Susie Strife and Bill Hayes, for organizing this wonderful event, and for our four excellent panelists for illuminating such a complicated topic so well. I hope you learned a lot. I know I did. Let's have a final round of applause for everyone. Thank you, and have a great lunch and rest of your day.